Hello there, and welcome to Science for Sleep. I'm really glad you're here. Maybe your eyes are already getting heavy, maybe the lights are low, and the sound of your world has softened into something still. You might be lying in bed, or maybe just sitting quietly, letting the edges of the day blur a little. Wherever you are, this space is here for you, steady, calm, and just curious enough to wander through something strange together. So, let's begin with a simple question. One that seems almost too obvious to ask. What time is it? Not the number on your phone, not the digital rhythm of your watch, but truly, what time is it where you are? And more than that, how do you know? How do you know that your now is the same as someone else's? Or even that what you see right now is happening now at all? You don't have to answer, just let it sit. And as you think about that, I'd like to thank you for sharing this moment with me. If this quiet corner of science helps you unwind, if it brings a little calm to your night or your mind, it would mean a lot if you liked the video, maybe even subscribed if you'd like more. And if you're listening from somewhere special, a city window, a tent under the stars, the quiet of your childhood bedroom, let me know. It's always wonderful to watch the map of bedtime glow softly from all the places we connect. Now, let's begin. Think about light. Not the concept, not the metaphor, just light, the real physical thing. The glow from your lamp, the blue of your screen, the pale shine of the moon through the window. Light seems fast, immediate, maybe even instant. It feels like when you switch something on, it's there. No delay. But that's not quite right. Light moves quickly, yes, incredibly so. But it doesn't cheat distance. It travels. It takes time. Even the light in this room is moving at a fixed speed, whether it's crossing your pillow or stretching across the cosmos. If you were to hold a mirror a few feet from your face, the image you see is not exactly what's happening right now. It's what just happened, a fraction of a second ago. A reflection, sure, but also a memory. That's not just a metaphor. Light left your face, hit the mirror, bounced back, and reached your eyes. And in that time, an unimaginably short slice of it, things already moved. Tiny changes, yes, but real ones. Now stretch that out. Think bigger. Think about the stars above you, the ones you maybe glimpsed on the way home tonight, or saw drawn in a childhood book. Their light has taken years to reach you. Not seconds, not minutes, not even days. Years, decades, centuries. When you look up at those stars, you aren't seeing them as they are. You're seeing them as they were, because the light you see now left them a long time ago and only just arrived. In a very real sense, those stars might not even be there anymore. They could have burned out, exploded, collapsed, and you'd never know. Not yet. That light travelled all this way through space, through time, through everything in between. It didn't rush, it didn't pause, it just moved, at the only speed it can move, about 300,000 kilometers per second. That sounds impossibly fast, and it is, in a way. But even at that speed, the universe is so vast that light takes time to cross it. The sun, which seems immediate and ever-present in the sky, is about 8 minutes away in terms of light. If the sun were to suddenly vanish, which don't worry it won't, you wouldn't know for 8 minutes. The warmth would keep coming, the light would keep shining, the sky would stay the same. Until the moment the last wave of light finally reached Earth and everything changed at once. So when we say light shows us the past, we're not being poetic, we're being literal. Everything you see, everything you look at, is a glimpse into a different moment. Some delays are so small they don't seem to matter, but others are immense, and some of the light reaching your eyes right now is old. Older than cities, older than species, older than our planet. That's not science fiction, that's astronomy, and here's where it gets even more strange. That delay between now and then depends on how far away the thing is and how long the light has been travelling. That means the universe isn't a single synchronized moment. It's a mix of countless timelines, all layered over each other, all arriving at you from different distances. You, sitting here right now, are surrounded by fragments of the past. You live inside a shell of it, a moving sphere of information, updated at the speed of light. And this brings us to a strange idea, one that physicists take seriously, and that we're going to drift into more deeply together. The idea that you might be living in someone else's past, not metaphorically, not romantically, but actually. Because light is a messenger, and it doesn't send instant updates. If someone on a planet 100 light years away were watching Earth through a telescope, and let's say they had a very good one, they wouldn't see you. They wouldn't see our cities, or satellites, or anything recent. They'd be watching 1994. They'd see a world between world wars. They'd see steam trains and silent films. They'd see what we were, not what we are. Because that's when the light they're seeing left Earth. Now flip it. What if you were looking at them? You'd be seeing their 1924, or their 1824, or maybe their prehistoric past. And if they're not there anymore, if they've disappeared, moved, collapsed, you wouldn't know. Not yet. Not until their light reaches you sometime in the future. The present, then, is a slippery idea. It isn't universal. It's local. It's yours. But it's not necessarily shared. Two people far apart don't agree on what now means. Because their nows are filled with different light, arriving at different times. And if you move fast enough, really fast, even more changes. Your now starts to drift from theirs. Your clock ticks differently, and what you call the present might stretch into someone else's future, or collapse into someone else's past. This is where Einstein stepped in, not with a fantasy, but with math. He showed us that time and space are linked, not separate threads, but one single fabric, spacetime. And in that fabric, everything depends on where you are, how fast you're moving, and what's near you. Gravity bends time, speed stretches it, and distance delays what you know. So again, ask yourself, what time is it? And then wonder, for just a moment, whether someone else, far away, might be seeing you as a memory, not your memory, theirs. That question, soft as it is, opens a doorway. It invites us to think of light not as something that reveals, but something that records, something that leaves a trace of what was and delivers it later. That star you see in the sky, it sent you a message 1,000 years ago, and it arrived just now. But what if someone saw your message, the one your body is sending right now in photons, in heat, in signals, 1,000 years from now? What if your image, your light, is someone else's ancient history? And what if their curiosity is the only reason you're still visible? You don't have to go far to feel how strange this gets. Even your reflection in a mirror, or in a spoon, or in the window at night, is a version of you that's slightly behind. If you could make that mirror very far away, light years away, the delay would grow, and the image wouldn't be from a second ago, but from years ago. You could, in theory, build a giant mirror a light year away, and in 2 years see what you looked like today. It wouldn't be live, it would be delayed, like watching a very old recording that just finished arriving. All of this points to a simple but deeply unsettling idea. The universe doesn't operate on shared time. There's no single now. There are just many layers of then, arriving at different speeds, depending on how far away they started. And every observer, every place, every object sees a different combination of those layers. Your brain synchronizes your world neatly. It feels whole. But out there, beyond your skin, time is stretching in all directions. Not because the laws are broken, but because they're consistent. Just stranger than we ever expected. So when you lie beneath the stars and feel a sense of wonder, maybe that's not just sentiment. Maybe it's your brain feeling the time difference. Maybe it's recognizing in some quiet way that the sky isn't just above you, it's behind you. You're looking at a wall of delayed memories. The past is still glowing. The question is, who is seeing yours? We're going to drift deeper into that. We'll explore what it means to observe something that no longer exists, or to be observed long after you've gone. But for now, just know this. Every light you see is a traveller. It has moved for years to find you, and when you see it, you're catching it in the final moment of its journey, not where it came from, just where it stopped. If you ask someone what time it is, they'll probably glance at a screen, 9:12 p.m. or 3:46 in the morning. It feels precise, mechanical, as if a digital number could anchor a moment, and in a way it does. It tells you when the sun might rise, when the alarm might ring, when the bakery opens. But ask the same question in a different way, not what time it says it is, but what time it really is, and the answer starts to drift. Because what you're reading isn't time itself, it's a system designed for humans, wrapped around planetary rhythms. The Earth spins, so we divided that spin into 24 slices, each slice into 60 pieces, each piece into more pieces. That system works well for organising life. But time itself doesn't care. It doesn't tick the way we think it does. And in some places, under some conditions, it doesn't tick the same at all. This becomes clear when you step outside the everyday scale and start looking at how the universe actually measures moments. Not with clocks, but with change. With movement, motion, delay. Time is what happens between events. The swing of a pendulum, the vibration of a crystal, the decay of a particle. These things don't ask for permission to happen. They just do. And when you line them up one after the other, you get something that feels like a flow. But that flow isn't steady everywhere. It depends on what's around, how fast you're moving, how much gravity is pulling on you. You don't need to take it on faith. It's been measured. In 1971, 4 atomic clocks were flown around the world aboard passenger jets. One set stayed on the ground. The others went eastward and westward around the Earth. When they reunited, they didn't match anymore. Not by much, tiny fractions of a second, but enough to confirm what theory had already told us. That motion changes time. Gravity changes time. Even height changes time. You can test it yourself. Place one atomic clock on the ground and one at the top of a tall mountain. Let them sit. Eventually the one higher up ticks slightly faster. Not because it's broken, but because it's farther from the Earth's gravity. And in the presence of weaker gravity, time stretches out. This is called gravitational time dilation, a concept from general relativity. But really, it's just what the universe does. Near something massive, a planet, a black hole, a star, time slows down. Not in perception, but in actual measurement. A second isn't always a second. It depends on where that second is being counted. So what time is it really? That depends on who's asking and where they are. Imagine 2 people standing on the surface of Earth. One is in a valley, the other on a mountain. They both check their watches. From their perspective, they agree on the time. But over a long enough period, the person on the mountain experiences slightly more time than the one in the valley. Their clock runs faster. Their body ages just a tiny bit more quickly. Their molecules tick forward a little more with each breath. They wouldn't notice, neither would you. But the math would. Zoom out and the effect grows. An astronaut on the International Space Station, circling Earth at over 17,000 miles per hour, is both farther from Earth's gravity and moving at incredible speed. That creates 2 effects. Time speeds up because they're in weaker gravity, and it slows down because they're moving quickly. The 2 influences push in opposite directions. Combined, they experience slightly less time than someone on Earth. GPS satellites must account for this constantly. The clocks on those satellites tick faster than Earth clocks by about 38 microseconds per day. It doesn't sound like much. But if we didn't correct for it, GPS positions would drift by kilometers every day. Your phone would get lost trying to guide you to the next street over. The entire navigation system would fall apart. We didn't build relativity into the GPS system because it was elegant. We built it in because it works. So when we ask what time it is, we're asking locally, for our specific place, our particular speed. And we can't assume that our version of now matches anyone else's. That brings us to a strange realization. If time can change based on speed and gravity, then now is not universal. It's not like a single beat that everyone hears at once. It's more like a flexible sheet, curved, stretched, wrinkled in different places. If you go far enough, or fast enough, or deep enough into a gravity well, your version of the present stops lining up with someone else's. You could leave Earth, travel near the speed of light, and return to find that while you've experienced only a few months, decades have passed here. Not because your clock was wrong, but because your path through time was different. That's not a story device. It's physics. It's been tested with particles called muons, which decay in predictable patterns. When those particles are accelerated to near-light speeds, their decay slows down. Their internal clocks tick slower. Time changes. The decay stretches out. Not in illusion, but in reality. This idea is sometimes called the relativity of simultaneity. It means that whether two events happen at the same time depends on who's observing. Two flashes of light might seem simultaneous to you, but to someone moving quickly past you, they could appear in sequence, one before the other. Time doesn't just stretch, it rearranges. All of this might seem abstract, like it belongs in labs or simulations, but it's not. It touches your life in subtle ways. Every satellite, every deep space probe, every particle accelerator must account for these shifts. The universe doesn't care what we think time should do. It just does what it does. And we follow, adjusting our measurements, realigning our expectations. It also changes how we think about distance. Because if light takes time to travel, then what you see is never the present. It's always delayed. The farther away something is, the older the image you're seeing. The sun is 8 minutes behind. The nearest star is over 4 years behind. Galaxies are millions of years behind. The further you look, the further into the past you're staring. And there's no way around that. No way to speed up light. No shortcut. Information has to obey those limits, which means the universe, as we see it, is an archive, not a live feed. You, right now, are receiving light from countless objects at countless distances, each one carrying a different version of the past. It would be impossible to say what the universe is doing now. All you can see is what it was doing, in fragments, long ago. And that raises another question. If someone out there were watching us, really watching, what would they see? The answer is simple, but strange. They would see our past, just as we see theirs. Suppose there's a planet 100 light years away with intelligent observers. Suppose they have a telescope powerful enough to resolve individual humans. What they'd be watching right now is Earth, as it was in 1925. They'd see biplanes and telegrams, people wearing hats, a very different world. They'd see long-dead people alive, and they'd have no idea that anything had changed. Because they're not seeing us now. They're seeing the light we sent out a century ago. That's how long it took to reach them. And now, remember, the same is true in reverse. When we look at them, we're seeing their past. If their civilization collapsed 50 years ago, we wouldn't know. We'd still be watching their earlier moments, their outgoing signals, their older light. In that sense, all observation is historical. All vision is delayed. All sight is bound by light speed. Even in your home, that rule holds. The light bouncing off your furniture took time to reach you. So did the sounds. Everything arrives a little late. Not enough to matter here. But at scale, it matters a great deal. That makes time harder to define than it first appears. It's not a single river. It's not the same for everyone. It depends on where you are, how fast you're going, and what direction you're facing in space-time. It bends, it warps, it waits, or it runs ahead. And the more we measure, the more we realize that time isn't a background. It's part of the stage. It participates in what happens. And so the question isn't just what time is it, but whose time are we talking about? There's no master clock in the sky, no universal second ticking for all things, just motion and mass and the way those things shape the flow of moments. And that brings us back to where you are now, still, quiet, listening. You have your own version of time, the one your body keeps, your thoughts follow, your heartbeat marks. But you're also surrounded by layers of other times. Light from the past, gravity that shapes your now, signals that are still on their way in. If someone watches you from far enough away, they'll see a version of you that no longer exists, but to them it will be present, alive, moving, real. That person, wherever they are, is living in your past, and you might be living in someone else's. The question is how far the message has travelled, and who, if anyone, is there to receive it. You might not think about it very often, but the moment you tilt your head back and look up at the sky, you're looking at a kind of archive, not just of stars or constellations, not just of galaxies or space dust, but of time itself. The sky above you is filled with old information, not old in the sense of forgotten, but old in the sense that it's delayed. Everything you're seeing has already happened. That might seem obvious when we talk about distant galaxies or the cosmic microwave background, but it applies to everything, even the moon, even the sun, even the starlight that feels familiar. If you could see past the atmosphere, past the brightness of the city or the cloud cover, and into the deeper, darker sky, you'd be staring into layers of the past. When you see the moon, you're seeing it as it was about 1.25 seconds ago. That's how long the light takes to travel from the moon's surface to your eyes. Not even enough time to think about it. But it's a delay all the same. The moon is never quite now. The sun is further. About 8 minutes, as we said before. If something changed on the surface of the sun, a flare, a burst, even something catastrophic, you'd find out almost 9 minutes after the fact. Not because the signal is slow, but because space is big. Light has limits. It doesn't skip ahead. That delay grows with distance. The nearest star system, Alpha Centauri, is about 4.37 light-years away. That means the light you see from it tonight left during the last US presidential term. The decisions made on Earth back then, elections, storms, discoveries, all happened after the light you're seeing began its trip. Go further, and the delays get longer. The Andromeda Galaxy, the closest spiral galaxy to ours, is over 2.5 million light-years away. That's the closest large neighbour we have, and its light began travelling toward us long before human civilization existed in any form, before writing, before tools, before humans. By the time that light reaches you, the world it left behind might not exist anymore, and yet we see it, clearly, brightly. It's one of the few galaxies visible to the naked eye in a dark sky. We see it not because it's present, but because the light is persistent. It kept moving. It kept coming. It didn't fade. And when it finally arrives, it tells a story that already ended. That's the trick of astronomy. It's not about observing what's happening. It's about observing what happened. Every image, every spectrum, every dot of light in a telescope is a message from some earlier moment. We don't know what those objects look like now. We only know what they looked like when their light began the journey. Even the images captured by powerful space telescopes, the colourful ones you might have seen online, filled with clusters and filaments and spiral arms, are built from ancient signals. Some of them are billions of years old. You're seeing the early universe not because we can go there, but because the light from those early events is only just reaching us. When you think of it like that, the sky becomes less like a place and more like a timeline. Each layer of distance is a layer of history. The closer the star, the more recent its light. The farther the galaxy, the further back in time you're looking. You can almost peel the sky like an onion. Layers of time, one on top of another. There's no shortcut to seeing the present. Not in space. Even the fastest signals obey the same limit. If you built a telescope that could resolve events on the other side of the galaxy, which you can't, but let's imagine, you'd still be seeing them from tens of thousands of years ago, because that's how long it takes the light to reach here. It's not that the universe is hiding its current state, it's just that distance builds delay, and the more distance, the older the data. That also means if someone is looking at Earth from a great distance, they're seeing an old version of us. This has been said before, but let's linger on it. Let's make it specific. Suppose there's a civilization 65 million light years away. Tonight, if they point a telescope at Earth, an impossibly advanced one, they're watching dinosaurs. They're seeing the final days of the Cretaceous period. Giant reptiles, tropical forests, a planet that hasn't yet cooled from the last wave of volcanic eruptions, and they'd have no idea that mammals exist, that humans will evolve, that cities and satellites will someday fill the planet. Now bring it in. A civilization 1,000 light years away sees us in the Middle Ages. No electricity, no cars, no radio, just fire, stone, paper and wood. Our entire technological revolution hasn't happened yet. Not to them. Not in the light they're receiving. That doesn't mean they're wrong. They're not seeing an illusion. They're seeing the truth. Just a very delayed truth. So what does it mean when you look up and see a star? It means you're connecting with something that already happened. You're seeing a part of the universe that no longer exists in quite the same way. Maybe the star is still burning. Maybe it's collapsed. Maybe it's gone. But the light is still travelling, and you're still receiving it. You never see the universe as it is, only as it was. This concept isn't just important for astronomy, it's also a clue about how causality works. Because light doesn't just bring us images, it brings us information. It's how we know what's out there. And that means our understanding of the universe is always a little behind. We make assumptions based on past light. We model the future based on ancient data. That doesn't make it unreliable, it just means our knowledge is layered. And the deeper we look, the older those layers become. Even within our own galaxy, the stars you see are a patchwork of timelines. Some are 10 light years away, some are hundreds, some are thousands. Their light left at different points in history. When you gaze at the sky, you're not seeing one unified moment. You're seeing a crowd of individual stories, all arriving late. That's why the phrase, looking up is looking back, isn't poetic. It's literal, it's physical, and it's always true. You might wonder if there's a way around it, some method to see things as they are now, not as they were. But there isn't, because the universe only communicates through signals, and all signals take time to travel, even hypothetical ones. Even the fastest theoretical methods still require time to cross space. And so, your entire view of the cosmos is shaped by distance and delay. You are, in effect, walking through a museum of starlight, one where the exhibits are still being delivered. The farther you look, the older the exhibit, the longer the wait. What's interesting is that we use this fact to our advantage. Astronomers actively look at older light to understand earlier times. When we talk about the early universe, we mean the light that left shortly after the Big Bang. Photons from over 13 billion years ago. We can't go back in time, but the light from those times is still arriving, slowly, reliably, and we collect it, analyze it, decode it. In doing so, we're not just studying the past, we're reconstructing it, piece by piece, signal by signal. And just like those astronomers, you too are receiving signals all the time, whether you're thinking about it or not. The stars are sending their messages, so are the planets, the galaxies, the background glow left over from the origin of everything. All of it is streaming in. Even your body is bathed in these messages. The light may not feel like much, but it's there, passing through the atmosphere, through your skin, into your eyes, filling the world with a quiet, steady record of what came before, that might make you feel small, or distant, or even disconnected. But it's also a kind of participation. You're not separate from the story, you're inside it. You're part of the process that receives the light and interprets it. Without observers, the light would just move on, undetected, unexamined, unappreciated. You're the endpoint of that journey, at least for a moment. And when you look up, not just glance, but really look, you're meeting those photons right as they arrive. They've been flying for years, decades, even eons, and the instant they hit your eyes, their trip ends. Not with a bang, but with perception. Quiet, personal, complete. It's strange to think that everything we know about the universe, its age, its shape, its history, comes from these late arrivals, that we build our models not on current data, but on time-shifted images. But that's how the cosmos works, not out of mystery, but because of speed. Because nothing can outpace a photon, and no information gets here faster. The night sky isn't a picture, it's a transmission. And every point of light is a message delayed. You don't need to understand every detail to grasp the weight of that. Just know that when you look up, you're not just seeing stars, you're seeing events, and those events have already ended. But the light found you anyway. Everything you see is made of light. That might not be the way we usually talk about vision, but it's what's happening. Every colour, every shadow, every shape that meets your eyes is built from light bouncing off surfaces and entering your body. When you look at something, a person, a tree, a planet, a star, what you're seeing is the light that left it, travelled through space and struck your retina. That's vision. Not contact, not direct knowledge, but reception. And every ray of that light comes from somewhere specific in time. It's easy to think of light as immediate. It feels that way. The lights in your home turn on with a switch. The flashlight on your phone works the instant you tap it. But even those sources emit light that travels. It just travels such a short distance that the delay is too tiny for you to notice. Technically, even the light crossing the width of your room takes time. But we round it off to 0. Out in space, the distances stretch, and the delay becomes obvious. And what you end up with, without meaning to, is a full sensory experience built from the past. Not metaphorically, literally. The photons entering your eyes are time travellers. They left their sources seconds, minutes, or years ago. They carry the last visible message from whatever object they came from. And that means every moment of visual experience is a kind of archive. You aren't seeing the world as it is, you're seeing the world as it was. In most daily contexts, this doesn't matter. You're not going to base your coffee choice on the speed of photons. But once you step into cosmic scales, or even moderately large distances, the delay becomes a defining feature. It's not a bug, it's the system. The light from the stars is the obvious example. But it's not just stars, it's anything visible. The surface of Mars is about 4 to 20 light minutes away, depending on its position. That means photos taken by rovers aren't showing you Mars now. They're showing you what it looked like several minutes ago. That delay affects how commands are sent and received, how events are recorded, how timing works. Every mission has to be based on the assumption that you're always reacting to the past. The further out we go, the more dramatic it gets. The Voyager spacecraft, still transmitting signals back from the outer reaches of the solar system, take hours to reply. A message sent to Voyager 1 right now won't reach it for over 20 hours, and any reply it sends will take just as long to get back. So even though the probe is active, we're communicating with a version of it that no longer exists. The one that sent the signal, the one that already moved on. The same is true of light from other galaxies. We see galaxies that are billions of light years away, and we observe them as they were billions of years ago. Some of them are interacting, colliding, forming stars. Some might no longer exist in the form we're seeing, their structures might have changed. Their cores might have collapsed. But their light is still arriving, as if it never stopped moving forward. What this tells us is that the past isn't gone in a universal sense. It's gone locally. But it continues to travel outward, encoded in light. The events that happened here, on Earth, in your town, in your own life, are radiating outward right now, carried in photons. Those photons will keep moving, carrying that version of you into deeper and deeper space. Eventually, those rays of light will be too diffuse, too weak, too scattered to detect. But they don't disappear. They're still moving. The record of you, what you look like, what you did, what light you reflected, is out there, just extremely faint. Someone with an unimaginably advanced telescope placed far enough away could intercept those rays and reconstruct a piece of history. Not a story told second-hand, but light that came directly from the source. This doesn't mean everything's recoverable. Most light doesn't carry high enough resolution to reconstruct the past in detail, and most signals are drowned out by cosmic noise. But in principle, the universe has no erase function. Once light leaves, it leaves, and unless it's absorbed, it keeps going. The past keeps moving forward, on paths measured in light years. You might be wondering if this applies to sound too. It doesn't, not in the same way. Sound needs a medium, air, water, or another substance. In the vacuum of space, there's nothing for sound waves to travel through. So while light spreads through the cosmos endlessly, sound does not. If you were floating outside a spaceship, you wouldn't hear anything. Not the engines, not the stars, not even your own breath. But the light would still be there, flowing outward in all directions, unbothered by the emptiness. This is why light becomes our primary way of knowing the universe. It's the only thing that travels fast enough, far enough, and consistently enough to inform us about what's out there. And in every one of those rays is a time code, a timestamp, a record of departure. Every observation is also a delay, and every delay is a glimpse into the past. That applies here on Earth as well. When you see a lightning strike, for instance, you often hear the thunder after you see the flash. That's because light travels faster than sound. You're watching something that already happened and then hearing it later. If the storm is far away, the gap between the two grows larger. Even your own reflection, depending on how far the light travels, is technically behind. A mirror on the wall doesn't feel delayed, but it is. A mirror on the moon would be more obvious. A mirror placed a few light years away, if such a thing were possible, would return your image years after you stood in front of it. All of this builds toward a strange truth. The past isn't confined to memory. It's not only inside your head, it's built into the structure of reality, carried outward by every photon, encoded in the light that leaves your body and your world. Some of it is intercepted, some of it is absorbed, but much of it keeps going. This also means that the past in some form is visible if you're far enough away and looking in the right direction. You don't have to imagine a time machine. The light itself is the machine. The star you're watching already lived, already burned, already ended, but it's still there in front of you, shining. And that contradiction is real. You can't use this fact to go back and change anything. You can't reach into the light and pull time backward, but you can use it to understand how your moment fits into a larger sequence. Because while your present is only yours, your image, the light version of you, is already in motion. It's strange to think about how far that image might go. Right now, light bouncing off your body is scattering in all directions. Most of it will fade. Some of it might reflect off other surfaces. But some fraction of it, infinitesimally small but still real, will escape the atmosphere and head into space. It will travel at light speed forever unless it runs into something, and it will carry with it a record, not of your thoughts or your words, but of your appearance, the way you bent the light in that moment, the way the present looked, even if it's no longer here. You could say that the universe keeps a visual journal. Every surface, every object, every star contributes to it, and that journal isn't stored in books, it's stored in motion. It's not kept in drawers, it's kept in rays. You're in that journal now simply by existing. It's not sentimental, it's just physics. Every ray of light carries a direction, a wavelength, and a history. When you absorb light, you stop that history. When you reflect it, you continue it. The past moves outward at the speed of light because there's nowhere else for it to go. This idea becomes even more interesting when we apply it to telescopes, because in a way, telescopes are just machines for looking further into the past. The bigger the telescope, the fainter the light it can catch, and the farther back it can see. This isn't just about zooming in, it's about going deeper into time, seeing older photons, catching earlier messages. And when astronomers point their telescopes at the deepest parts of space, they're not hoping to see the present. They're deliberately looking for the past. Because the past tells them how things started, how they grew, how they changed. The past is the only version we're allowed to access, and so we gather it. Not because it's nostalgic, but because it's available. You do something similar without thinking. When you see a candle flicker or sunlight move across a room, you're collecting delayed information. You just don't feel the delay. But it's there, built in. The difference is scale. And the farther you go, the more the delay matters, the more the ray reveals, and the more you start to realize that the present is a very narrow thing, just a knife edge between what's arriving and what's already left. And right now, as you lie still or sit quietly, your own body is part of that system. You're a source of light, a reflector, a participant in the timeline of photons. You're not just watching the past, you're sending your own version of it outward. Eventually, that version will fade into background noise. It will stretch too thin to be useful, but not right away, and not entirely. And in the meantime, you are both observer and signal, watching and being watched, not necessarily by anyone in particular, but by the system, by the process, by the structure that holds light and time together. That past, your past, everyone's past, isn't erased. It's just distributed, one ray at a time. And now, with that idea sitting somewhere in the back of your mind, you can start to ask new questions. If the past travels outward in light, and the present is just the moment it leaves, then what happens when that light meets something else? What happens when it's received? Not by a telescope, not by a machine, but by someone. You probably don't feel it, but every time you move through space, you're also moving through time. That's not a poetic idea. It's built into the way the universe works. You're not just walking from one place to another. You're threading yourself through a fabric that has both length and duration. Space and time aren't separate. They're connected. One influences the other. If that's true, and it is, then there's a consequence we don't often think about. That the farther apart two things are in space, the more separated they also are in time. You can't look at something far away without also looking into the past, and the greater the distance, the greater the delay. It's unavoidable, it's structural. That separation between here and there becomes a separation between now and then. The numbers add up quickly. Light travels fast, roughly 300,000 kilometers every second. But space is unimaginably large. Even the light from the sun, which feels instant, is over 8 minutes old by the time it hits your skin. You step outside into the warmth of the afternoon and feel a version of the sun that's already moved on. The moon is closer, so the delay is shorter, just a little over a second. But once you move beyond the solar system, the distance becomes so vast that you're always looking back in time, sometimes by centuries or more. We say this out loud all the time. That star is 100 light years away. That galaxy is 2 million light years away. But it's easy to forget what that really means. It means we are seeing them not as they are, but as they were. Their now is ahead of us, unreachable, unseeable. Our view is always historical, a kind of visual lag baked into the nature of space itself. This isn't a distortion. It's not like a video buffering on a weak connection. It's more fundamental than that. It's not a flaw, it's a boundary, a limit set by physics. No matter how much technology improves, no matter how powerful our telescopes become, we'll never see something distant as it is now. Only as it was when the light began its journey. There's no way around it. No lens that can catch up. because even if you built a telescope that could somehow magnify perfectly, it would still be limited by the speed of the signal. Information moves at a maximum pace, light speed, and even that isn't fast enough to close the gap. So every observation we make is built on delay. Even nearby stars are slightly out of date. When we model the universe, we're working with a fragmented timeline. We gather pieces from various distances, which means various ages, and try to reconstruct what's happening. But we'll never see it as a whole, synchronized picture. That's not how reality allows itself to be known. Imagine a vast room filled with windows. Each one shows a different moment in history, depending on how far away it's focused. Some show last year, some show the Middle Ages, some show the time before Earth even existed, but none show the present. That's what the sky is like. Even the light from Earth is subject to this. As it escapes into space, it carries snapshots of our now. But by the time it reaches anywhere meaningful, it's no longer current. If there's a planet 1,000 light years away with an observatory pointed at us, they're watching what happened here 1,000 years ago. The Crusades, castles, written language just starting to spread. They have no idea we exist, at least not as we are now. And the same goes for us. When we detect a signal from deep space, a radio pulse or a flash of X-rays, we're catching something old. Not ancient by cosmic standards necessarily, but definitely not fresh. The event we're analysing already happened. We're just the delayed audience. The universe doesn't send you anything live. It doesn't do real time. All you get are recordings. That's the consequence of distance. And so, when we talk about living in someone else's past, we're not being speculative. We're describing the actual condition of the cosmos, the structure of how vision and communication work across vast spaces. You can never be fully present with anything far away. Not visually, not informationally. You're always seeing what it used to be, not what it is. That applies to every photon you've ever caught, every star you've ever admired, every nebula you've seen through a telescope. You saw them all as they were, not as they are, and you always will. The difference between now and then is written in the gap between here and there. This idea doesn't just affect astronomy. It has implications for everything we believe about knowledge, about observation, about certainty. If the data you're receiving is always old, then your understanding of the universe is a reconstruction, not a direct report. You're working from artifacts, from echoes, from messages that have taken a long time to reach you. It would be like trying to understand a person by reading letters they sent hundreds of years ago. The letters are real. They tell you something meaningful. But they don't reflect the current moment. They're evidence, not presence. That's how it is with starlight, with distant planets, with deep field images from space telescopes. They're incredibly valuable, but they're always partial, always late, and there's a hidden beauty in that. Because while you can't know what's happening now, you can still know what happened then. And sometimes that's more than enough. Sometimes that's everything. Because that past is still arriving. It's not gone, it's not erased. It's coming in every direction, constantly, filling your sky with fragments of what was. Not imagination, not memory, but actual physical light, arriving now from events that happened long ago. This means that time isn't just something you experience inside your own head. It's something you see, something you catch, something that arrives. And that's different from how we usually think of time. We're used to the idea of clocks, of moments passing, of the future becoming the present and then turning into the past. But in space, it works differently. The past is still active, still travelling, still findable if you know where to look. There's something about that that's both comforting and unsettling, because it means that every moment leaves a trace, every event sends out light, and that light moves on forever. Most of it will never be seen. It will pass through empty space, unnoticed, unmeasured, but it still exists. It still carries information. You can't get it back once it's gone, but someone far away might still be watching it. And that brings up a question we rarely ask. How far back are we being seen? If the light from Earth is moving outward in a sphere, then someone, somewhere, might be watching our past right now. Not theoretically, but literally. And what does that say about our own image in the universe? That everything we do becomes a visual record travelling into deep space, that our actions, our lights, our broadcasts, even our reflections are expanding outward, moment by moment. It makes the idea of now feel small, not in a bad way, just in a grounded way. Your now is yours, but it's not the whole story, because someone else's now is your past, and your now is their future, still on its way to them. When you stand still and look up, you're not just looking at distance, you're looking at delay. You're looking at things that no longer exist in the way you're seeing them, and yet they're still here, visually, informationally, functionally. It's a strange kind of duality. The thing is gone, but the light remains, and in that light, a version of the thing continues. The more you think about it, the more the idea of simultaneity starts to fall apart. There is no universal now, just overlapping spheres of perception, each centered around a point, each receiving a different combination of pasts. You can't see everything as it is, but you can see where it came from. You can trace the rays back to their sources, and if you do that carefully enough, you can reconstruct something meaningful. You can map the difference between now and then, not to erase the gap, but to understand it, to make peace with it, to work within it. Because there's no escaping it. The universe gives you signals, but it doesn't give them quickly, and so you listen, you receive, you interpret, and you build your version of reality from the rays that arrive. They're always late, but they're always honest. If you could hold two identical clocks, one in each hand, and then place them in different locations, you'd expect them to keep time the same way. Identical mechanisms, identical beginnings, nothing to throw them off. But if you leave them long enough, you'll notice something strange. They won't match anymore. One will tick faster than the other, and it won't be a malfunction. It'll be the result of where they were placed, how fast they moved, and how close they sat to something massive. Time, it turns out, isn't a constant rhythm echoing through the universe. It's more like a flexible pattern, shaped by conditions. It can stretch, it can compress, it can pass more quickly or more slowly depending on how you interact with space, gravity and motion. And because of that, time isn't quite the same for everyone. It depends, specifically, on where you stand. You experience this difference all the time without noticing. Gravity pulls you toward the Earth, and your position relative to the center of that gravity affects how time passes for you. Higher up, on a mountain, in an airplane, even on the top floor of a building, your body experiences slightly weaker gravity. And in weaker gravity, time runs just a little faster, not by much, just a few billionths of a second over a year. Nothing you'd ever notice, but it's there, and it can be measured. If you go the other direction, closer to a massive body, time slows down. That's not a theory, that's reality. In fact, the clocks aboard GPS satellites tick faster than clocks on Earth, because they're farther from the planet's gravity. If we didn't correct for that difference, navigation systems would drift by miles every day. Our maps, our directions, our positions, all of it would become useless within hours. Even the International Space Station experiences time differently. It orbits Earth at high speed and at a relatively low altitude. Those two factors interact in a strange way. The speed of the orbit causes time to slow down, while the slightly weaker gravity causes it to speed up. The result is a net time difference, just enough to be measurable. That effect is part of Einstein's theory of general relativity. The idea that mass bends space and time around it, and that this curvature affects the way time flows. The closer you are to a massive object, the more your timeline bends along with the space around you. Time moves slower because the path through space-time is more warped. There's no intuitive metaphor for it. It doesn't behave like something else you've seen. You have to trust the data and the predictions that match what's observed. If you take two synchronized atomic clocks and place them at different altitudes, or move one at high speed, they diverge. They stay accurate to their own frame of reference, but when compared side by side later, they disagree. It isn't a glitch, it's a fact. The faster you move, or the closer you are to a heavy object, the more time slows down for you relative to someone else. The difference might be tiny at earthly scales, but it grows the more extreme the conditions. In practical terms, you can think of time as something you experience locally, like weather. It might be raining where you are and sunny a few miles away. You don't notice the boundary until you cross it. Time works similarly. Everyone moves through it at a slightly different rate depending on their circumstances. There's no universal present ticking the same way everywhere. This becomes clearer when we start to talk about speed. If you're stationary, time flows at one rate. If you begin to move, especially if you move very fast, time begins to slow down for you relative to people who stay still. This is time dilation, part of special relativity. It's not a side effect or illusion. It's a measurable change in how time progresses. Particles called muons, created when cosmic rays hit Earth's atmosphere, live for only a fraction of a second. But when they move close to the speed of light, their lifespans appear to stretch. They survive longer than they should, because time, from their perspective, is unfolding differently. We see them live longer, not because they've changed, but because their clocks are ticking more slowly than ours. You can apply the same logic to humans, though we haven't travelled fast enough yet to notice a meaningful difference. But in principle, if you boarded a spaceship that travelled near light speed and returned after a short trip, you'd have aged less than the people who stayed behind. Not because you experienced time wrong, but because your timeline was stretched differently. It's been called the twin paradox. One twin travels at near light speed, the other stays on Earth. When they reunite, the travelling twin is younger, not by imagination or memory, by biology. Their heart beat fewer times, their cells divided less often, their clock ran slower. That's not science fiction, that's science. Time passes differently depending on your velocity. It's not a metaphor or a trick of perception. It's baked into the mathematics of how space and time work together. And you don't have to be moving fast or standing near a black hole to experience this. It's happening all the time. Right now, your feet are aging more slowly than your head, by an incredibly tiny margin, because they're closer to the centre of Earth's gravity. Your body spans a time gradient. It's measurable. It's real. It's just too subtle for your senses to detect. What this means is that everyone is, in some sense, in their own personal time. Not isolated completely, but shifted, tilted, slightly out of sync. It raises strange questions about simultaneity, about what it even means for two things to happen at the same time. If you and I see an event at the same moment, but we're moving differently or standing at different altitudes, we're not experiencing the same tick of the universal clock. Because there is no universal clock, there's just local time. Your time, my time, the time of the moon, the time of a passing satellite, the time inside the dense core of a star. Time becomes relative to position and motion. Two observers might agree on the order of events, but not the intervals between them. They might disagree on what counts as simultaneous, and they would both be correct, according to their own frame of reference. The universe doesn't enforce a single timeline. It allows for many, each one legitimate, each one slightly curved by the path the observer takes. And once you understand that, the idea of the present starts to blur. If time flows differently for everyone depending on where they are, then your now isn't mine, and mine isn't yours. Even if we're close, even if we think we're synchronized, there's a gap. A tiny one, but still a gap. That gap grows with distance and speed. If you're moving rapidly away from me, your time slows down relative to mine. If you're accelerating through a strong gravitational field, your timeline bends more sharply. And if you're far enough away, the light that carries your version of now takes so long to reach me that it might as well be a historical document. That's what makes space so deceptive. We see stars and galaxies and think we're witnessing the universe as it is, but we're not. We're seeing it as it was. And our time is different from its time. Always. There's no way to sync up with something far away, no way to jump into its present moment. All you can do is receive what it sent long ago and try to reconstruct its story. So when someone asks what time is it there, the only honest answer is, it depends. It depends on your location, your motion, your altitude, your velocity, your proximity to gravity. It depends on how you've curved through space-time. Even if we build two perfect clocks and synchronize them side by side, the moment they begin to travel different paths, they start to disagree. Not because one is broken, because they are simply experiencing time differently. And so are we. You might not feel the difference. You might not see it, but it's there, in the background, in the numbers, in the measurements. It adds up over long distances and high speeds. It shifts our frames of reference, and eventually it forces us to abandon the idea that time is the same everywhere. Because it isn't. It's elastic, responsive, local, and that means every moment you live, every second you count is yours, and yours alone. It's not wrong. It's just specific, and someone standing far away from you, or moving very fast, or orbiting something massive, will experience that same second differently. You can call that strange, or you can call it a deeper kind of order, a system where time adapts to circumstance, where no two paths through the universe are quite the same, and if time is personal, then so is history, so is the past, so is the present. Everything you know is shaped by how and where you move through the structure. There's more to say about how time connects across these distances, how messages pass between observers, how the speed of light builds delay into our understanding of reality. But for now, the important thing is this. Time isn't fixed, it isn't flat, it isn't universal, it's flexible, it responds to position, it reacts to motion. And because of that, no two clocks are ever truly the same. If you've ever hiked up a mountain, you've probably felt the change. The air gets thinner, the wind sharper, the temperature drops. But there's something else changing too. Something you wouldn't feel and couldn't detect without a very specific kind of equipment. Up there, above the sea and the soil, time is passing just a little bit faster than it is at the bottom. Not metaphorically, not in perception. In measurable terms, seconds tick more quickly the farther you are from Earth's centre. The gravity at the top is weaker than at the base, and where gravity weakens, time stretches. It's not a theory, it's a verified observation. This effect is one of the more subtle and surprising consequences of general relativity. You don't need to be orbiting a black hole or flying at the edge of light speed to experience time dilation. You just need altitude. Not much, either. A few meters makes a difference. In fact, some of the most elegant demonstrations of gravitational time dilation involve nothing more than mountains, towers, and carefully synchronized clocks. At the Eiffel-Keating experiment in 1971, atomic clocks were flown around the world and then compared with those that stayed on the ground. The results matched Einstein's predictions. Time for the clocks in motion passed differently than for the ones that remained still. But the same principles had already been demonstrated on Earth by elevating one atomic clock slightly above another and letting them run. In 2010, physicists at the National Institute of Standards and Technology placed two aluminum-ion clocks just 33 centimeters apart, roughly the distance from your foot to your knee. Even at that small separation, they detected a difference in the passage of time. The higher clock ran slightly faster. The conclusion was clear: elevation matters. When you're on top of a mountain, you're experiencing more time than someone standing at sea level. Not in hours or minutes, but in the smallest increments measurable, nanoseconds, picoseconds, even less. The higher you go, the less curved space-time is around you, and the more room time has to breathe. If you could live your whole life on top of Everest, and your identical twin lived below sea level, you'd end up slightly older. Not by much, But older, just the same, you would have aged more, lived more seconds, experienced more total time. Not because your body did anything different, but because the world around you bent time less. And that's the key idea. Time bends. Not as a metaphor for change or stress, but as a literal consequence of mass. Gravity isn't just a force pulling you downward. It's a distortion in the shape of space and time. And the deeper you sit in that distortion, the more it affects the passage of time. It's hard to visualize. You might imagine a heavy ball on a trampoline pulling the surface downward, but in reality it's not just the surface, it's the entire structure. And time is part of that structure. So when gravity pulls space into a curve, time gets curved with it. And in those curves, clocks tick more slowly. At everyday altitudes, the difference is small. But it scales. If you were standing on the surface of a white dwarf, a super-dense remnant of a dead star, time would slow dramatically. Your seconds would stretch compared to someone standing far away in open space. And if you approach the event horizon of a black hole, time would slow so much that, from the perspective of someone watching from a distance, you'd appear to freeze. Not just move slowly, freeze. They would never see you cross the horizon. Just slow down, asymptotically, until you stopped. That's what gravity does to time. It doesn't just pull on mass, it pulls on sequence, it pulls on duration. And that idea brings us back to the mountain. Because even here, on Earth, with modest elevation changes, the same principles apply. Every vertical foot creates a slight time shift. Every increase in altitude is an increase in how much time you get to experience, by an incredibly small amount, but one that's real. Satellites in orbit experience this constantly. GPS satellites are tens of thousands of kilometers above Earth's surface, where gravity is significantly weaker. Their clocks tick faster than those on the ground by about 45 microseconds per day. But they're also moving quickly, over 14,000 kilometers per hour, which causes time to slow for them. The net result is that they gain about 38 microseconds each day compared to Earth clocks. That number sounds trivial, but if we didn't adjust for it, GPS systems would accumulate errors of around 10 kilometers per day. Your navigation app wouldn't just be off, it would be unusable. We didn't design GPS to test relativity, but we couldn't make it work without it. The point is that this isn't theoretical. It's embedded into how our systems function. We build technology around the fact that time passes differently depending on altitude and velocity, that people in planes age a little faster than people on the ground, that satellites experience a different timeline entirely. So when we ask how time behaves, we're not just asking a philosophical question, we're describing a measurable property of the world, and that property depends precisely and always on where you are. If you're high, time moves a bit faster. If you're low, time slows down. If you move quickly, time stretches. If you hover near something massive, time compresses. You can see this concept as a kind of natural clock distortion. Not all seconds are created equal. They might be labelled the same, 60 per minute, 3,600 per hour. But in reality, they vary depending on how gravity shapes them, and the difference grows with mass. Earth creates noticeable but small distortions. The sun warps time more. Neutron stars bend it significantly, and black holes push it to the extreme. But the principle is the same everywhere. Time responds to gravity, and the result is that everyone is on a slightly different path through time, based on how gravity touches them. It's easy to ignore. It doesn't change your daily rhythm, but it's there. Your morning routine, your heartbeat, your sleep cycles, all unfolding on a slightly altered version of time, shaped by your elevation, your speed, and your place in the curvature of space-time. In that sense, there is no absolute clock to refer to, no global standard that defines real time for everyone. We use atomic clocks and coordinate systems to keep things consistent, but those systems are layered on top of something more flexible, something that changes moment to moment, place to place. Even a simple thought experiment reveals how strange this becomes. Imagine two people, one in an underground laboratory and one on a mountaintop. They each hold identical watches. At the start of the experiment, the watches are synchronized. Over the years, as they live and work, the clocks continue to tick. But eventually they disagree. One has moved ahead, and the people themselves, they've diverged as well. They're aging, their cellular processes, their physical experience of time, slightly different. Not enough to notice, but enough to matter. That's not just philosophy, that's physics. It forces us to rethink our assumptions about time as a shared experience. Because if the rate of time's passage depends on location, then now isn't flat. It's curved, sloped, stretched. It tilts toward mass and warps with motion. And that realization opens up new ways to think about the universe. It means that there is no single frame of reference that works for all observers. There's no central clock, no master timeline, just many overlapping frames, each with its own version of events, shaped by gravity and velocity. It also means that some of the things we take for granted, like simultaneous events, don't really exist outside of our limited perspective. If you say two things happened at the same time, you're describing your own frame. But someone else, moving differently or standing elsewhere in a gravitational field, might see those same events happen in a different order, and they wouldn't be wrong. There's no contradiction. Just different paths through space-time. The mountain then becomes more than just a place. It's a vantage point for a different version of time. Climb high enough, and your seconds stretch. Stay low, and they compress. Not metaphorically, but measurably. It's subtle, but it's always active. You live your life in a time field that's constantly changing, shaped by everything from the earth beneath your feet to the altitude of your bed. Your frame of reference moves with you. It defines the world you perceive, and while it may seem like everything around you shares that timeline, that's only locally true. Go far enough, or fast enough, and the differences start to matter. They start to accumulate. And they remind us that time is not a universal flow. It's a personal trajectory, which means the clock on the mountain isn't broken. It's just higher, and it's telling the truth, as only it can. When you think of something moving fast, what comes to mind? Maybe a jet cutting through the sky, a bullet fired from a rifle, a lightning strike. These are fast by human standards, but none of them come close to the speed that dominates the cosmos, the speed of light. It isn't just quick, it's absolute. It's the maximum speed limit for the universe, the line that nothing with mass can cross. 300,000 kilometers per second. That's how fast light moves in a vacuum, fast enough to travel around the Earth more than 7 times in a single second. Fast enough that you never see it in transit. You only see the result, the arrival, the illumination. It feels instant, but it's not. There's always a delay, always a moment between departure and arrival, a gap that we can't sense directly, but that always exists. Even the light bouncing off the screen you're looking at had to leave the display, travel a short distance through the air and reach your eyes. That trip took time, not much, just nanoseconds, but time all the same. If you compare that to how fast a thought moves, or how quickly your brain forms an image, light still wins. A nerve signal travels down your arm at a few hundred kilometers per hour. Light moves at more than 1 billion. If you fired a beam of light and then tried to react, even with perfect reflexes, you'd always be behind. That's not a limitation of your body, it's the hierarchy of speed. Light doesn't wait. But even though it's the fastest thing in existence, light still isn't immediate. And over large distances, that not quite immediacy becomes the defining feature. You see a flash of lightning, and you hear the thunder afterward. Not because sound is slower than thought, but because sound travels through air at a crawl compared to light. Light gets there first, always, and over larger distances the delay stretches. A light signal from the moon takes just over a second to reach Earth, from the sun just over 8 minutes, from Jupiter anywhere from 30 to 50 minutes depending on orbit. Those delays aren't guesses, they're constants. The space between you and the source defines the lag. There's no way to skip it. So when we receive light from a distant star or a deep space probe or a galaxy far from ours, we're not seeing anything happen now. We're seeing the result of a journey, a trip that started long ago. Sometimes before your birth, sometimes before humans existed at all. And the journey of light isn't just about its speed, it's about how that speed shapes what we can know. Imagine sending a message to a spacecraft at Mars. Depending on where the planets are, it takes between 4 and 24 minutes for your message to arrive. Then, it takes the same amount of time for the reply to come back. That's close to an hour just to complete one exchange. There's no real-time conversation, no immediate feedback, just waiting. This happens constantly with our robotic explorers. Commands are issued hours in advance. Responses are interpreted long after the fact. If something goes wrong on the spacecraft, the signal we receive might already be minutes old. And by the time we send a fix, the situation may have changed again. The faster you want to go, the more this delay matters. Imagine trying to pilot a spaceship travelling at half the speed of light. From Earth, every instruction you send would arrive far too late. The vessel would have already travelled millions of kilometres by the time the signal got there. There's no catching up, no course correction in real time. The same principle applies to observation. If something explodes on a distant planet, a supervolcano, a lightning storm, a collapse, we won't know until the light gets here. We might see it as it happens, but what we call now is actually then, delayed by distance. No matter how fast we process the image, or how quickly the telescope relays the data, we're seeing a past event. It may look current, but it's not. And it works in reverse too. If an observer on a distant planet is watching Earth, they aren't seeing your world as it is. They're seeing the version of Earth that existed when the light left, 1,000 years ago, 10,000, 100,000. The farther away they are, the deeper into Earth's past they're looking. That's not just a strange thought. It's a structural feature of how the universe communicates. Light doesn't just illuminate, it encodes, and the information it carries is always behind. Even at the edge of human perception, this delay exists. A mirror half a metre away reflects your image with a round-trip light time of about 3 nanoseconds. In your brain, visual processing takes about 100 milliseconds. So while the light delay is shorter than your awareness, it's still real. Your reflection isn't of your now, it's of your slightly earlier self, always. This is what gives rise to the idea of living in a distributed past. Everyone is seeing a version of the world defined not by the present state of things, but by how long the light has taken to reach them. You can't see someone else's now, only their then. We build technologies to work around this. We synchronize clocks with atomic precision. We triangulate positions using satellite constellations. We stream live events with delays so short they feel immediate. But under the surface, the lag remains. The photons still travel at the same pace. The distance still dictates the delay. Think about a spacecraft orbiting Saturn. Signals take more than an hour to reach Earth, and yet, when we watch footage, it looks like it's happening right now, but it's not. We're seeing what already happened, edited by time and framed by delay. Even more extreme are the radio signals we receive from galaxies millions of light years away. We detect pulses and flares and emissions that originated before humans evolved, before mammals existed, sometimes before Earth even formed, and we treat those signals as news, as fresh data. But they're older than our species. That's the scale we work on when dealing with space. Light gives us the ability to observe the universe, but it also puts a cap on how quickly we can know anything. No matter how advanced we become, we can't go faster than light, which means we can't get information faster than light allows. This becomes even more fascinating when you consider that, from the perspective of a photon, the trip is instantaneous. Light doesn't experience time the way we do. It travels at the speed that makes time from its frame collapse to zero. No clocks tick from the moment of emission to the moment of absorption. For the photon, the journey doesn't take time, it simply happens. But for us, outside the frame of the photon, the journey stretches. We measure it in seconds, minutes, years, eons, and the further the distance, the more history gets packed into the beam. There's a duality there. To us, light moves fast, but never fast enough. To light, there's no delay at all. That tension defines so much of how we interact with the universe. We receive light late, but not too late. We see stars that burned out but still shine in our sky. We watch events that ended long before we were born, and we send out our own light, reflections, emissions, broadcasts, into a universe that will receive them much later, if at all. Our presence is always slightly ahead of our perception. Even on Earth this is true. The sun warms your skin with light that left its surface over 8 minutes ago. You react to stimuli after processing them. Your sense of now is stitched together from events that already happened. And when you look at someone across a room, the light from their face reaches you after a small delay. A few nanoseconds, maybe. But even then, you're seeing a version of them that's technically out of date. What this builds toward is the idea that perception isn't real time. It can't be. There's always a gap, however small, a space between the moment something happens and the moment you experience it. Faster than a thought, slower than a moment. That's light. And that delay, the time between emission and reception, isn't a flaw. It's part of the structure. It gives us time to interpret, to react, to build understanding out of waves and signals and images. But it also means we're never fully caught up. The world we see is always a little behind, a little older than we realize, and so are we. You're living in a timeline that's constantly adjusting, continuously catching up, built on signals that left their sources long before you encountered them. The difference between immediacy and perception is small but constant. And if you want to understand the universe, you have to understand that everything you know, everything you see, comes with a delay, a distance, encoded in time. You'll never quite be current, but you'll always be receiving. Wherever there is light, there is also a shadow. You've seen it every day of your life. A tree casting shade on the sidewalk, your silhouette moving along a wall, a building blocking the sun. But shadows aren't just absence, they're artifacts. They tell you something was there. Something intercepted the light, broke its path, and left a quiet outline in its place. But there's something else happening behind every shadow, something most people don't think about, a detail hidden in the delay between the source and the surface. Because while the shadow feels instant, like it forms the moment you move, there's always a whisper of time in between, not loud enough to notice, but present, real, the result of light taking just long enough to make the interaction slightly after the fact. Think about what a shadow is. It's not just darkness, it's a record of blocked information. The light that would have illuminated that space was intercepted. It never arrived. What you're left with is the shape of the interruption. But that shape isn't current, it's delayed. It forms because light was heading toward a surface, and something got in the way just before the beam could complete its journey. So the shadow isn't about what's happening now, it's about what just happened. There's always a slight difference between when the object moved and when the absence of light appears. The delay is tiny, nanoseconds, maybe even less, but it's built into the system. Because light, though fast, is not immediate. It travels, and that travel time separates the source from the surface. That means even the simplest shadow carries a kind of lag, a quiet whisper that what you're seeing is not quite now. It's almost now. Just behind, just barely. And it's not just with moving shadows, even the still ones, the ones cast by buildings or cliffs or your own motionless body, are based on light that's arriving late. The sunlight on your shoulder left the sun 8 minutes ago. So the shadow it casts is a response to something that happened in the past. You're creating a current shape out of old information. That interplay between the arriving light and the blocking object is a kind of conversation. The light says, "This is what I've seen," and the shadow replies, "This is what I'm hiding." But the words are never spoken at the same time. One always trails the other. It gets stranger when you scale it up. A lunar eclipse, for example, is the Earth casting a shadow on the moon. You can see it unfold. The shadow creeps across the surface, taking slow bites out of the brightness. But the entire process is built on delay. Light from the sun, interrupted by Earth, takes just over a second to reach the moon. Then, the reflected light from the moon takes another second to reach us. Everything you're watching already happened. The geometry is real, but the timing is not quite synchronized, and it keeps going. During solar eclipses, the moon blocks the sun and casts a shadow on Earth. That shadow races across the planet at thousands of kilometers per hour. But even that racing darkness is made from light that left the sun over 8 minutes before the eclipse began. We're seeing a shadow that began its life more than 8 minutes earlier, shaped by light that's just now arriving. Even the sharpest shadows, the ones with clean lines, are soft on a cosmic timeline. They're responses to light that travelled through space, carried its message, and only then encountered something in its way. If you build a sensitive enough system, a set of instruments that measure the arrival time of photons down to the smallest fractions of a second, you can track these delays. You can measure the precise time it takes for a shadow to form after a light source is activated, and you can confirm again and again that nothing in the visible world is immediate. Everything responds to signals in motion. You can think of a shadow as a kind of silent photograph, but instead of capturing what something is, it captures where something refused to let light go. It's the imprint of an obstruction, the outline of interruption. And the longer the light travels, the older that interruption is by the time it appears. This becomes even more interesting when the light source is far away. A street lamp across the road creates near-instant shadows. A star hundreds of light years away does not. If you could somehow see the shadow your body casts from starlight on some distant screen, it would be shaped by your position years ago, maybe decades, maybe more. It's not easy to perceive, but it's true. The shadows we create from distant light sources are shadows of our past selves. They form not because of where we are now, but because of where we were when the light started its journey. It works in reverse too. Imagine a planet orbiting a star 500 light years from Earth. If that planet happens to transit the star, passing in front of it from our perspective, we might detect a dip in the starlight, a slight dimming, a tiny shadow. That's how many exoplanets have been discovered, but that shadow isn't current. It's a record of a movement that happened 5 centuries ago. By the time the shadow reached us, the planet may have changed, the orbit may have shifted, the system may not even exist anymore, but the evidence is still arriving. The shape of that ancient shadow still tells us something true about what used to be. In this way, every shadow becomes a kind of messenger, a delayed report from a different place and a different moment. Even the shadows you see on Earth, fleeting as they are, participate in that system. A moving train casting flickers along a tunnel wall, a child running under a tree scattering silhouettes across the grass. The images aren't just a reflection of light, they're responses to delay, to motion meeting arrival, to the mismatch between a source and a surface. And all of this plays out constantly, everywhere, without pause. Look at your own hand in the light of a desk lamp, see the shadow fall across the table. That shape, familiar, soft-edged, immediate, isn't fully present. It's based on light that took time to arrive, light that left the bulb, travelled to your hand, then missed the table because of you. That's the missing light you're seeing. That's the whisper. It doesn't feel old, but it is. This layering of time behind every shadow extends into how we interpret vision, presence, and movement. Because if light always travels, and shadows are interruptions in that travel, then everything you see is a combination of signals received and signals refused. What's illuminated is what made it through, What's dark is what didn't. And so the world around you is not just brightness and colour, it's an active negotiation. The surfaces you see are engaged in a constant conversation with light. Accept this, reflect that, block the rest. You're witnessing that negotiation second by second. And every shadow you see is an answer to a question you didn't know was being asked. Sometimes the shadow tells you what's in the way. Solid object, a tree trunk, a wall. Sometimes it tells you what used to be there. A car that just passed. A person who just left the room. The shadow lingers slightly longer, fading with the last rays, echoing the shape of something that's gone. Not quite in memory. Still too recent for that. But gone just the same. This gives shadows a strange status. They're not fully physical, but they're not imaginary. They exist as the absence of something. They're shaped by interruption. And they persist just long enough to be seen before fading into the next phase of light. You might think of them as disposable, temporary, but they're also records, each one a brief summary of light's journey and what interrupted it. They trace the edge of the reel, and in that edge you find time, not measured in hours or minutes, but in delay. And if you keep watching, you start to realize that light never quite keeps up with the world it tries to reveal. It's always just behind, always catching up, always delivering the story just a little late. Shadows are how you can see that lag with your own eyes. They're not just visual, they're temporal. They form because light had a plan and something changed before it could complete it. And so, every shadow contains a trace of that change. The whisper is always there. The whisper behind every shadow, telling you what light tried to show, telling you what almost arrived. It doesn't matter how fast you move or how bright the light is. The system remains. Motion meets delay. Signal meets surface. Obstruction meets outline. And what you see is never quite now. You've looked in mirrors your entire life. In the bathroom. In store windows. In car side panels. You know the face that looks back at you. You know the angle of your eyes, the shape of your mouth, the little movements you make when you're thinking, or frowning, or just checking if your hair is doing what you want it to do. But that face you're seeing, that familiar image, it isn't you. Not exactly. It's a version of you that already happened, a light-based echo, a visual memory, just slightly behind the real event. You see yourself, and you assume it's now. But it's not. The reflection is always late. That delay is tiny, of course. If the mirror is right in front of you, the light that forms your reflection takes only nanoseconds to complete the trip. It leaves your body, hits the surface of the glass, and bounces back into your eyes, maybe a meter or two of total travel. At light speed, that's basically instant, but not quite. If you could measure the delay, you'd find it's there, just not perceptible to your mind. Light takes time to move, and so your reflection is not simultaneous. It's a memory, not stored in your brain, but embedded in the behavior of photons. The mirror doesn't invent anything. It doesn't predict. It doesn't anticipate. It responds to what arrives, and what arrives is always from the past. We don't think of it that way, because we're used to treating vision as real time. You look and you see. No lag, no buffer, no delay. But that immediacy is only an illusion of scale. If your mirror were placed farther away, 10 meters, 100, 1,000, the delay would grow. Still imperceptible, maybe, but measurable, eventually noticeable, eventually undeniable. In space, we've used mirrors like this, placed reflectors on the moon during the Apollo missions. When we fire a laser at one of those retro reflectors, the beam travels over 380,000 kilometers to the lunar surface, bounces off, and returns to Earth. The round-trip journey takes about 2.5 seconds. So when we detect the return signal, we're catching light that left Earth over a second ago, touched something far away, and made its way back. That's what your reflection is, just on a smaller scale. A message bouncing back with a timestamp, a piece of visual information returning from an interaction. But the moment it shows is not the moment you moved, it's the moment after. That principle doesn't change no matter how short the distance is. All reflections are delayed. All of them show you something that just happened, not something that is still happening. There is no mirror in the universe that can show you now. And it's not just mirrors. Any reflective surface does the same thing. A pool of water, a window at night, a polished metal panel. They all respond to light that already left you. The scene they show is recent, but never current. If you were somehow able to freeze yourself in time and trace the path of the photons bouncing off your body, you could watch them travel outward, bouncing off surfaces, hitting walls, reaching eyes, passing into lenses. All of those encounters would happen after you stopped. The light would keep moving. The image would still be forming even though you were no longer changing. That's how reflections work. They don't need you to still be doing the thing. They just need the light that left when you did it. And that's the same for everything you see, not just yourself. You're constantly receiving light from the past, from surfaces around you, from the sky above, from the screens in front of you. You're never seeing anything as it is. You're only seeing how it looked when the light left it. The difference with your own reflection is that you assume it's more accurate, because it feels immediate, and because it feels like you, but it's still built on the same delay. If you placed a mirror 1 light year away and looked into it, you would see your own face from 2 years ago, the light taking 1 year to reach the mirror and another year to return. You'd be looking at a memory carved into space by the behavior of photons, reconstructed without your input. No thought, no nostalgia, just light, moving along a path, following physics. And if that sounds like a thought experiment, it's only because we don't normally deal with distances that large. But the principles are constant. In fact, this is one of the ways we think about looking deep into the universe. A telescope isn't just a zoom lens, it's a time machine. The farther it looks, the older the light it collects. And what we see through it isn't a simulation of the past. It's the past itself, still travelling, still arriving, still being caught by our mirrors. Every reflection is a timestamp, and when you think about it that way, your daily routine starts to feel different. You brush your teeth in the morning and watch your face in the mirror. You adjust your clothes, make eye contact with yourself, smile or frown. You're not just checking your appearance, you're watching a signal return. A delay short enough to ignore, but not short enough to deny. The mirror is reporting on your past self, the one from nanoseconds ago, the one who has already left the moment. And as strange as that seems, it's always been true. Even before you knew what light was, even before you had a concept of reflection, the system was in place. The laws didn't care whether you understood them. You stand in front of glass, and the past stares back. It becomes even stranger when you add movement. When you wave or blink or tilt your head, you're watching that movement repeat itself in your reflection, but only after it happened. Not a full second later, but behind nonetheless. There is no version of your reflection that runs in parallel with you. It's always catching up. The difference is small, but so is the distance between perception and reality. And in that smallness lives everything we misunderstand about vision. You might ask why this matters. If the delay is so small, why care? But the significance isn't in the number, it's in the fact that there's no exception. The delay is always there. The light is always behind. The image is always old. And once you accept that, it changes how you think about presence. Because presence in visual terms doesn't exist. Not the way you thought. You can't see something as it is, only as it was. The world you see is a moving gallery of memories, not yours, but the world's. Reflected back at you, moment by moment, through the paths light takes. Even photographs are just snapshots of this principle. A camera captures light from the past. Your selfie is already behind by the time the sensor records it. Your face in the photo was never captured in the present. Only in the moment light reached the lens. Your reflection is just a real-time version of that process, a live feed of the past, and when you turn away from the mirror, the light you bounce continues. It travels on. It might scatter, or be absorbed, or continue into darkness, but it's out there, a version of your moment moving forward. Invisible, undetectable, but still real. It won't last forever. Most light eventually dissipates, but in principle, it continues. It carries the memory of your motion, your presence, your shape, and somewhere far away, unimaginably distant, that light could still be travelling. Your image, your reflection, your delay, still unfolding across space. It's not poetry, it's physics, and it means that every reflection you've ever seen is already over. You saw it, but it wasn't you anymore, just close enough to believe. So the next time you look in a mirror, take a second. Remember what you're really seeing, not your face, not this instant, but the light that remembers you, just barely. If you've ever stepped outside at night and looked up, you've seen them. Stars scattered across the sky like scattered memory, steady in their flicker, some bright, some dim, each of them seemingly alive in the vast blackness. But what you're looking at isn't what's there, not anymore. Some of those stars may have already gone dark. Some might not even exist anymore. And the reason you still see them is simple. The light they cast is still on its way to you. That light may have started travelling hundreds, even thousands of years ago. It crossed the emptiness of space, uninterrupted, never stopping, never slowing down. And by the time it finally reached Earth, by the time it hit your eyes, the star that emitted it might have already exploded, collapsed, burned out entirely. What you saw, glowing faintly above you, wasn't the star as it is now. It was the star as it was then, before it ended. This isn't a trick of perspective. It's a physical truth. Light has a finite speed, and space is vast. So everything you see in the night sky is old, some of it very old, and you can't tell by looking which stars are still there and which ones have gone quiet. The only thing you can see is the light that left when they were still burning. That idea alone can stop you in your tracks. That the stars that feel most eternal, the ones you wish on, the ones used for navigation, the ones embedded in ancient myth, might not exist anymore. That they died long ago, quietly, without your knowing, and that you've been looking at their past this entire time. But it's not just possible, it's inevitable. Take the star Betelgeuse, for example. It's one of the brightest stars in the Orion constellation, easily visible from Earth with the naked eye. It's also a red supergiant nearing the end of its life. Astronomers believe it could go supernova any time within the next 100,000 years. Maybe sooner, maybe already. And that's the key. Maybe already. Because Betelgeuse is about 640 light years away. If it exploded yesterday, we wouldn't know until 640 years from now. The light from the explosion wouldn't reach us until then. Until that signal finally arrives, we will continue seeing it as it was, still flickering, still alive. When the supernova light does reach us, whenever it happens, it'll be the announcement of something that already happened. Not in our now, but in our distant past. We'll be watching history in real time. That principle applies to everything you see when you look deep into space. Every galaxy, every nebula, every distant sun. Their images are messengers from another era. Some of the galaxies captured by our most powerful telescopes are billions of light years away. That means the light we're collecting today left those galaxies before Earth had trees, before there were animals, before oxygen had even accumulated in our atmosphere. We're not just seeing distance, we're seeing prehistory. We're seeing cosmic events that occurred when the universe was young, long before life ever began here. And that's what it means to say that you might be living in someone else's past. Because the light that's just now arriving, the image that's just now appearing, isn't of something current. It's delayed by distance, shaped by travel. The events already happened. We're just the late audience. When a star dies, it does so in silence. Not because it's quiet, but because sound doesn't travel through space. There's no atmosphere to carry the wave. So the death of a star Even one as violent as a supernova sends no sound at all, just light, radiation, a final flash that races outward in all directions. That light moves quickly, but not instantly. So while the star itself collapses in a moment, the story of that collapse takes centuries or millennia to reach its viewers, and by the time it does, the stage has long since emptied. You see the curtain fall, but the actors are already gone. This raises a strange kind of question. If something has ceased to exist but its light is still visible, is it still real? What does it mean to exist when the only evidence available is outdated? What does it mean to observe when your entire field of view is built from lagging signals? You might be tempted to say, it's not real anymore. The star is gone. What you're seeing is fake. But it isn't fake. It's real light, real energy, really arriving. It's just not current. And that distinction matters. Because while the source is gone, the signal isn't. And in physics, the signal is everything. We map out the cosmos using light that has long outlived its origin. We build models based on remnants. We study events by analysing echoes. And it works. It works so well that we can measure the chemical composition of stars that died before humanity existed. We're not guessing. We're receiving. And the universe gives freely, just slowly. If you were to take a spaceship to one of those stars, you wouldn't see what you saw from Earth. You'd see whatever is there now, maybe a black hole, maybe a cloud of gas, maybe nothing at all. But that version of it is invisible from here, because the light from that change hasn't reached us yet. So you have two different truths, the one visible here and the one happening there. They don't match, but both are valid within their own frames of reference, and that mismatch is permanent. You can never see a distant object as it is, only as it was. So when you look at the stars, you're not just seeing the night sky, you're looking into time, into layers of history, into a composite of eras, woven together by photons. Each star is a message, and each message comes with a delay. The younger the star appears, the closer it likely is. The older it appears, the farther its light has travelled. You're watching a layered sky, not a simultaneous one. Some of those layers include stars that have already died. Their collapse is done. Their remnants are scattered, but their light keeps coming, so you still see them, like ghosts with perfect timing, arriving just late enough to linger, and sometimes that light can outlive its origin by vast margins. A small star might burn out, but the light it emitted in its final years could travel for millennia, passing through the void, brushing past dust, avoiding absorption, and finally landing on a lens or a sensor or your eye. And in that instant, the star lives again. Not truly, but visually, informationally. Because in the end, the light is all we have. It's the way we know anything exists. It's the way we locate, measure, understand. And when the source disappears, the light becomes its only evidence. That's why the night sky is never about what is. It's always about what was. And yet it feels alive. Because the light is still arriving. Because the story is still being told. So when you make a wish on a star, that star might already be gone. But the wish is still real. Because the light made it, and you caught it. Every time light leaves a surface, it carries information with it. Details about colour, shape, temperature, composition. And once that light has gone, you can't pull it back. You can't rewind or redirect it. It's already out there, travelling forward, whether anyone's watching or not. That light contains the imprint of a moment, a version of reality that no longer exists, and depending on where you stand and how long you wait, that moment might arrive in your future, though it already left long ago. It's a strange idea, that what you're going to see tomorrow has already started its journey, that parts of your future are on their way to you, riding on beams of light, slipping through the gaps between stars, waiting for the right time to be seen. It happens constantly. Most of the signals you'll receive over the rest of your life have already been sent. Some of them are in transit now. Some have been travelling for minutes, others for centuries, a few for billions of years. All of them will arrive at their appointed time, though the events they represent are long gone. We talk about seeing the past, and that's easy to grasp. Looking up at the stars, watching light that left hundreds of years ago. But it also means something else. Every second that passes, your field of view changes. Not because anything moved, but because something reached you. Something that was always headed this way. Something that belonged to a future moment. From your point of view, but had already departed long ago. There's no control over when these things arrive. You can't speed them up. You can't skip ahead. All you can do is wait for the signal to catch you. That's what makes this so different from memory. Memory moves backwards. Light moves forward. You recall what's been. But light delivers what has already gone, right on time, as if it were happening now. And it's not just about stars. Even everyday things work this way. The sunlight you'll feel on your arm tomorrow afternoon left the sun more than 8 minutes before it reaches you. It's already left the surface. It's already travelling. It just hasn't gotten here yet. And when it does, you'll feel warmth from a source that is, in every measurable way, not where you think it is. The sun won't be where it looks like it is. Because light takes time, and in those 8 minutes the sun moves. Earth moves. Everything shifts slightly. But the light doesn't know that. It just goes straight, unaware of any change in direction. So the warmth you'll feel and the brightness you'll see will be based on a location the sun no longer occupies, a position it already passed through. You'll be bathing in a version of its past, even as that past becomes your present. It's not a glitch, it's a pattern, and once you start to see it, it's everywhere. The light from your own face, reflected in a window at night, left your skin and travelled back to your eyes in a fraction of a second. You're watching your own past self, even if it feels like now. The difference is tiny, but the principle never changes. When we detect signals from distant galaxies, radio waves, gamma rays, infrared pulses, we're receiving records from times so old they defy imagination. We call them data. We measure them, catalogue them, write papers about them. But what we're really doing is listening to a universe that already said what it had to say. We just weren't here to hear it when it spoke. So we catch the message late. Imagine someone lighting a flare on a mountaintop. They send it up into the night sky, and it glows red against the dark. You, standing miles away, don't see it immediately. But the light is coming, already in motion. By the time it reaches you, the flare is out. The person has left. The moment is over. But you're only just witnessing it. That's the future from your point of view. A flare that's already been lit. You're not there yet, but the signal is on its way. It works in the other direction too. Right now, light is leaving Earth. Every reflection, every emission, every broadcast, it all travels outward. And some of it will keep going forever. It won't stop. It won't fade. It will just keep expanding, moving into deeper space, waiting to be caught. And if somewhere out there, an observer looks back, through a powerful enough telescope with a clear enough line of sight, they won't see Earth as it is. They'll see it as it was. Maybe years ago, maybe centuries, maybe longer. That version of Earth is still out there, still visible to anyone in the right position, at the right time. Our past is someone else's future view. And what that means is that everything happening now on this planet, every conversation, every movement, every emission of light, is joining that stream. It's leaving, heading out, becoming part of a future someone else might witness. Even if no one ever does, the information is still moving. The idea that the future has already left isn't abstract. It's measurable. You can calculate it. You can predict what light will arrive tomorrow, next week, next year. You can trace its origin, model its delay, and determine exactly when and where it will become visible. The universe is filled with these pre-sent messages, not predictions, just facts on a journey. They're not waiting to happen. They already did. They're not going to change. They're just going to arrive. Think about a supernova from a galaxy 2 million light years away. That explosion happened 2 million years ago. The light from it left at that moment and has been travelling ever since. It hasn't slowed down. It hasn't stopped. It's just been moving. And when that light reaches Earth, maybe tonight, maybe tomorrow, we'll see the sky flash. We'll register it as something happening now, but the event is long over. All we're seeing is the light that finally arrived, and that same thing is happening right now, in all directions. Light is coming toward us that left its source centuries ago. Thousands of sources. Millions. Most of them unnoticed. Most of them quiet. But all of them carrying evidence. All of them bearing stories. They're not all dramatic. Some are faint glows from background galaxies. Some are quiet pulses from stars in other arms of the Milky Way. Some are barely detectable, but they're coming, and they will keep coming. So the next time you wonder what's coming tomorrow, remember, part of tomorrow has already begun. It just hasn't reached you yet. It's already in the sky, already moving toward you, already written. We don't always know what that light will show when it gets here. We can't always interpret the meaning in advance, but we know it's on its way. The sky is filled with things you haven't seen yet, not because they haven't happened, but because they haven't arrived, and by the time they do, they'll be folded into your present, integrated into your now, but always from somewhere else, and always from before. It shifts how you think about time. You're not moving forward through a blank slate. You're entering a field already filled with signals, with images and stories and energy that left their origin long ago. The future isn't empty, it's full of light, and all of it is already en route. Most of the time, when we talk about light travelling through space, we talk about what we're seeing. We look at the stars and we say, that's how they looked long ago. We understand that their light left before it reached us, but we rarely stop to think about the fact that we're doing the same thing, right now, without even trying. You're not just looking out at the past, you're also broadcasting it. Right now, as you sit or walk or lie still, light is bouncing off you. Off your clothes, your skin, your hair. It reflects outward in every direction. Some of it is absorbed, some scattered, but much of it continues on, into the open world, through the air, through windows, into the sky. And from there, it just keeps going. That light doesn't stop, it doesn't turn around, it doesn't slow down. Once it leaves forever. And as it travels, it carries a message. A small, detailed snapshot of what was happening when it left. That message is specific. It includes the temperature of your skin, the wavelengths of the light in the room, the exact moment when you turned your head or blinked or stood up. That information is carried by the photons themselves. They don't carry a picture. They carry the data that, under the right conditions, could be used to reconstruct one. We don't usually think of ourselves as sources of data for the universe, but we are. Everything we've ever done that involved light, every movement made in sunlight, every reflection in a window, every illuminated scene, has already begun moving outward. It's gone, past the clouds, past the atmosphere, past the moon. Every moment you've ever lived in light has already left Earth behind. That light doesn't vanish. It gets weaker, yes. It spreads, it dilutes, but it keeps going. And given enough time and distance, it becomes possible, in theory, for someone, or something, to catch it. You are right now someone else's future image. You just haven't been seen yet. If there were an observer on a planet 10 light years away with an impossibly powerful telescope, one that could capture single photons and reconstruct complete visual scenes, they could watch you as you were 10 years ago. They could see the version of you that stood somewhere on this planet a decade in the past. Not metaphorically, literally. Because that light is already on its way. It left back then. It's been moving through space the entire time, and at this moment it's reaching the edge of their perception. It's difficult to imagine, because we think of space as a place we look into. Not a place we're being seen from, but it's both. We're not just watchers. We're participants. Every second of every day, We're sending out our story to the universe, not by choice, but by physics. It's baked into how light works, and it means that everything you are is leaving an imprint not just on the people around you, but on the fabric of the cosmos itself. A visible record, a trail of images, forever moving outward. You don't need to be famous. You don't need to be loud. Just existing in the presence of light is enough. That's all it takes. And the universe takes that record seriously. It never asks what's important. It never prioritizes. It simply lets the information move. So if someone far away, at the right distance, pointed their attention here, they wouldn't be seeing your now. They'd be watching your then, your earlier self, the one that existed when the light they're just receiving first left Earth. And that process has no reverse. Once the light has gone, it can't come back. It carries no sense of time. It doesn't age. It just moves. It also doesn't wait for permission. You don't decide what gets sent. You don't choose which version of yourself leaves. The light takes what it sees, and that version becomes the one that travels. It happens during your most meaningful moments, your quietest ones, your unnoticed ones. They all go. There's no filter, and that's why you are and always will be someone else's past. Even if no one ever watches, the possibility remains. Even if the light never lands on another planet or enters another eye, it's still out there. It still exists. Our planet itself is bright. It reflects light. It radiates energy. We emit radio waves, television signals, satellite transmissions, all of them moving outward. The first television broadcasts from the 1930s have now travelled nearly 100 light years. They're still expanding into space, a sphere of electromagnetic history, growing every second. The first images of world leaders, wars, sports, advertisements, cartoons, all of it is now far outside our solar system. Our culture's earlier signals are no longer here. They're out there. That includes the light reflected off our cities, our oceans, our forests. It includes the collective glow of streetlights, porch lights, headlights, phone screens. It includes us. Each of us is a light source. Small, yes, but real. And that light adds up. It contributes to a glow that surrounds Earth, a bubble of our electromagnetic past, our image, travelling in every direction, becoming someone else's history. The idea that you are someone's past raises strange questions. What if someone is watching? What if they see Earth, not as it is, but as it was? What if they look at us and see ancient cities, older technologies, extinct species? What if they find our light long after we're gone? They wouldn't see ruins. They'd see the version of us from when the light left. The green trees, the moving clouds, the surface alive with motion, maybe even people walking, working, laughing. They'd see us unaware, doing ordinary things, and to them that would be our truth, because that's the only version of us they have. That's the cost of distance. It edits the present. It replaces it with what was. It also makes you consider what we're doing now, not for the sake of the future here, but for the one somewhere else. The story we're exporting is invisible to us, but permanent to anyone who receives it. There's no way to stop it. There's no way to silence light once it's gone, and that gives every moment an unexpected weight. Even your smallest movements are part of a story being carried into deep space. It's not a story you can edit. You don't get to revise it. There's no playback, no post-processing. The light doesn't wait for the best angle or the right version of you. It just records what is. And what is becomes what was. And what was becomes what someone else will eventually see. You've already been seen. You just don't know it. And even if you never are, the fact remains. The universe already received you. It accepted your light. It let you in. You're not outside the cosmos. You're part of its memory. And right now, your light is leaving again. Right now, this second, this breath, this movement, it's already headed outward, already en route to some unknown destination. Someone someday may catch it, and when they do, they'll be looking at you. Not the version reading this now, but the one that was here when the light left. That version still exists, somewhere in transit. That version is already someone else's past. There's no silence in space, not really. It's quiet in the way a blank sheet of paper is quiet. Nothing obvious, no noise, but full of potential. Full of signals waiting to be found. Full of movement that's too slow, or too far, or too faint to feel. But it's not still. It never has been. Everything out there is in motion. Galaxies are rotating, stars are orbiting, planets are spinning. Particles are drifting. Light is always on the move, always in transit. The universe never stops expanding, never rests, never pauses. And yet, when you stand still, when you just breathe and let your thoughts settle, it feels like everything has stopped. Just for a moment, just long enough to notice it. A quiet place inside the motion. A stillness so brief and so narrow that you can almost miss it, but somehow it feels like the most grounded thing you know. That moment, that sensation of now, isn't a property of time. It's a property of perception. The brain's best guess about when you are. The center point it builds between the signals it receives and the time it takes to process them. You feel like you're in the present, but you aren't. Not really. You're lagging behind by a fraction of a second. Your senses gather information, but it takes time to become conscious of it. Your mind stitches it all together and tells you this is now, but what it's really doing is smoothing out the past. It's a pause, but not in time. It's a pause in you. And that pause is happening in the middle of everything else, all of history, all of the future, all of space, all of motion. That single breath of stillness is surrounded on every side by movement you can't see and change you can't control. It's tempting to think of that moment as small, insignificant, just one flicker in a chain of events that stretches infinitely in both directions. But it's not small, it's local, it's the one place in the entire universe where your experience is happening. The only place where the past, the future, and the incoming stream of light meet. From your perspective, everything converges here. Signals from stars, pulses from satellites, echoes from other people, reflections from walls, sound waves through air, thermal gradients on your skin. Thousands of separate paths, all arriving now. That's what makes this moment feel so full, not because everything is stopping, but because everything is arriving. You're always at the crossroads of what was and what's next, always surrounded by data in motion, always receiving, always a little behind, but never completely disconnected. And yet, you never feel the complexity. You just feel present, anchored, focused on a point you can't define, but always return to. That's the illusion. And it's also the truth. You exist in a system of motion so enormous, so deeply layered, that your mind has no choice but to simplify it, to compress it into one idea, here, now. But this now is a blend, a patchwork of signals from different origins and different times, the light from your screen, the sound of your own breath, the warmth of your body, the gravity beneath your feet. They're all arriving from different places, moving at different speeds shaped by different events. They don't actually meet at one instant. Your perception makes them meet. It takes separate timelines and turns them into one experience. That's the pause. That's the space between the chaos. Not a break in the universe, a calibration inside you. And it's necessary. Without it, nothing would make sense. You'd be overwhelmed by delay, conflict, misalignment. You wouldn't know what happened first, or what belongs to whom, or what it means. So the mind steps in. It says, this is one moment, and everything fits inside it. But the universe doesn't pause with you. It keeps going. It was already going before you were born. It will keep going long after. The light will continue outward. The galaxies will continue their slow, cold drift, and the signals you emit, whether through movement or warmth or light, will keep leaving. That's what makes this moment so strange. It feels isolated, but it's not. It's deeply connected to everything else. It's one frame in a film that never ends, one point on a map that can't be finished, and the only thing you can be sure of is that this point, this version of now, won't last. It doesn't have to be dramatic. You don't need a countdown. The moment will change on its own quietly like it always does. A shift in attention, a slight delay in a signal, a flicker of new information, the arrival of light that's been travelling for centuries, and suddenly you're somewhere else. Not geographically, but temporally, internally. The stillness is gone, and in its place another moment takes over. Another experience builds. You can never hold on to the pause. You can only move with it. You're always just catching up, and that's not a flaw. It's the only way you can be conscious of time at all, because forever doesn't feel like anything. It doesn't register. There's no reference point, no comparison, no shift. It just is. But a pause? That's something. That's where time becomes personal. That's where meaning happens. And even if it only lasts a second or less, it's enough to remind you that you exist in the middle of all of it. Not at the edge, not outside, but in the centre of your own experience, watching light arrive. This idea changes how you think about time. Time isn't a river flowing over you. It's a sequence of arrivals, not external, internal. And what you do in those moments, how you respond, what you choose to focus on, those things define your version of the universe, your version of the story. The rest is still out there, still on the way. The pause doesn't stop the future from coming. It doesn't undo the past. It doesn't isolate you from the system. It just gives you a place to stand, a place to notice, a place to decide, and then it's gone, and something else takes its place. You move on. The light changes, the signals shift, the data updates, and the moment you just inhabited becomes part of your own memory. It joins the collection of images already leaving your body, already on their way out, already joining the expanding record of everything that's ever happened. From the outside, it looks like continuity, smooth, unbroken. But from the inside, it's a series of distinct pauses, each one convincing you that this is now, and that now is all that matters. It's not wrong, but it's incomplete. You're living in the middle of a broadcast that never ends. The station doesn't turn off. The light doesn't wait. The universe keeps projecting itself forward, and every once in a while you feel it. A pause that belongs to you. Not the world's pause. Your pause. And that's enough. The idea of memory is simple when it's personal. You remember a face, a smell, a sentence. Your brain stores it, rewires around it, brings it back when something triggers the connection. It's not perfect, not permanent, not always accurate, but it's yours. Memory as you know it is the residue of attention. But what about the universe? What does it remember? It doesn't have a brain. It doesn't write anything down. It doesn't recognize faces, doesn't revisit childhood, doesn't grieve or long or recall. And yet everything that's ever happened still leaves something behind. A signal, a trace, a pattern that wasn't there before. You move your hand through the air and you disturb molecules. You walk across the ground and you bend gravity. You speak and sound waves push outward and light bounces off your skin and carries that movement into space. You don't leave memory in the traditional sense. You leave records, physical, continuous, silent records. Some are fleeting, like a footprint in sand erased by the next breeze. Others last longer, fossils, erosion, layers of sediment, and some go farther. The light bouncing off you right now is already on its way out. In theory, someone or something could intercept that light centuries from now and reconstruct this moment. Maybe not perfectly, maybe not completely, but enough to know that you were here. From that perspective, the universe doesn't forget. It just doesn't organize. It's not a scrapbook. It's not a filing cabinet. It's a system that keeps moving, and whatever you put into it keeps moving too. Energy doesn't vanish. Information doesn't unhappen. Once something is encoded in the behavior of particles, it stays that way until it's absorbed or transformed, and even when it's transformed, it's not lost, just rewritten, folded into a different form. So can the universe remember you? Yes, but not all at once, and not in the way you do. It remembers in pieces, in trajectories, in the way your mass affected the Earth's orbit, however slightly, in the way your warmth radiated outward, causing tiny changes in local infrared emission, in the photons you scattered, in the electrons you displaced, in the entropy you increased, in the signals you emitted, whether intentionally or not. You are part of the data stream, whether you mean to be or not. You don't get to opt out of physics. You're part of the system. You can't erase your participation. You've already influenced things you'll never see. You've left a signature on air you'll never breathe again. You've caused slight changes in the pressure of surfaces you've touched, in the energy distribution of rooms you've passed through, in the chemical balance of environments you were never aware of. The scale is small, but the record is real. It doesn't need to be significant to be permanent. That's something we forget. Memory in the human sense is always selective. We hold on to what feels important, but the universe doesn't make that distinction. It doesn't care if something was meaningful, it only cares whether it happened, and when it does, it adds it to the ongoing computation. Some of your light has already left the solar system. It's travelling outward, part of an expanding shell of electromagnetic history surrounding this planet. It doesn't contain your name or your voice, but it contains your outline, your thermal profile, a brief echo of your existence. That light won't stop. It won't come back. It's part of the outbound memory of Earth. You're already being remembered, whether anyone is watching or not. And while most of that information may never be recovered, may never be seen, it still counts. Because in the structure of the universe, memory is measured in change, not sentiment, not nostalgia, just difference. If you made a difference, you're remembered. Sometimes that difference is large, a landslide, a shout, a discovery. But most of the time, it's quiet, a motion, a breath, a single photon bounced in a new direction. And yet, all of it adds up. The cumulative impact of your existence on every system you've passed through. This idea changes how you see memory. It shifts it from something internal to something universal. Memory isn't just what you hold, it's what you leave, and you're leaving it constantly. Every electron that moves through your phone, every step that depresses the floor slightly, every tiny vibration your voice sends into the walls, those things happen, and once they happen, they can't unhappen. They become part of the state of things. They push time forward. So even if you think you're unimportant, even if no one remembers what you said, or what you did, or who you were, the universe does. Not with reverence, not with judgment, just with structure. It's not a memorial, it's a ledger. The laws of physics don't forget, they adjust. If you remove a planet from a solar system, every orbit changes. If you remove a particle from a system, the distribution shifts. If you alter a wave, it never returns to its previous form. The echo continues, just with new constraints, and that's what you are. A constraint that the universe had to work around. A deviation from symmetry. A story written into energy. There's even a principle in physics, the conservation of information, that suggests information can never be destroyed. Even when things seem lost, the information about them still exists in some form, scrambled, spread out, unrecognizable, but present. Some theorists believe that even the matter swallowed by black holes leaves traces in the event horizon, subtly encoded. The information doesn't vanish, it's embedded in the boundary, preserved at the cost of comprehensibility. That means even in the most extreme environment the universe knows, where time and space fold in on themselves, memory still matters. Your body is made of atoms forged in stars. That's not metaphor, that's nuclear history. The calcium in your teeth, the iron in your blood, the carbon in your skin, those didn't form on Earth. They were built in the heart of exploding stars billions of years ago. So in one sense, the universe remembered you before you even existed. It just didn't know your shape yet. And when you're gone, it won't forget. It'll redistribute the parts. They'll move on, join other systems, form other structures. Your atoms will do what they've always done, respond to force, carry charge, reflect light. They'll leave new records, they'll contribute to new stories, and in that way, the universe isn't a place you pass through. It's a place you participate in, a system that gets altered by your presence. You don't need to believe in permanence. You just need to accept continuity. The light doesn't stop when you do. There's a feeling you sometimes get when you're walking through a place you've never been before. Maybe it's a street at night with dim lighting and uneven pavement. Maybe it's a room in an old house where the furniture has been moved but the indentations in the carpet are still there. A sensation that things have already happened, that something's already been written here, even if you weren't part of it. You don't always know what caused that feeling. It's not tied to a specific memory. It's not déjà vu exactly. It's quieter than that. A sense that the space around you remembers things you don't. But what if it's not just a feeling? There's an idea in physics called determinism. It suggests that if you knew every variable, every particle's position and momentum, every force in play, you could calculate everything that's going to happen. Not just generally, but specifically. Every event, every outcome, every decision. Not because the future is fixed by fate, but because it follows rules. Rules that, once set in motion, lead to only one possible conclusion. The problem is, we never know all the variables. We never will. There's too much noise, too much uncertainty, too many layers of interaction. And in quantum mechanics, uncertainty isn't just ignorance. It's baked in. There's a limit to what can be known, even in principle. So we don't live in a clean, predictable simulation. We live in a probabilistic one. Events don't unfold like pages in a book. They unfold like branches in a windstorm. Every possibility exists until it doesn't. Still, you can't shake the feeling that some parts of your life follow a pattern. You look back and things seem to line up. A chance encounter that led to a job. A missed train that made you meet someone. A book you picked up for no reason that ended up saying exactly what you needed to hear. Those moments feel written, placed. Not by someone else necessarily, but by something. As if the story already had a shape and you're discovering it one frame at a time. That feeling isn't proof, but it's not useless either, because while the future may not be fixed, the past is layered, and some of those layers are still unfolding in your present. The signals you receive today, light from distant stars, gravity from moving masses, chemical patterns from ancient processes, were all set in motion long before you were born. They were shaped by things that happened eons ago, and yet they're still arriving, still affecting you, still being incorporated into your version of the world. In that sense, you are living in a story already told, not because your choices don't matter, but because the information that builds your experience was written long before you got here. It's not just starlight, it's the temperature of the air around you, the shape of the land beneath your feet, the DNA that defines how your body works. All of those are historical. All of them were established by systems you didn't choose. Your consciousness exists inside a framework. That framework isn't fixed, but it's inherited. You can't reset it. You can only work within it. Even your own memories are shaped by past events you didn't witness. Your language, your culture, your sense of identity. You're not just making things up as you go, you're adapting to a structure already in place. And that structure extends beyond biology. It goes into physics. The universe has rules. Some we've discovered, some we haven't. But they apply equally everywhere. They're not reactive. They don't wait to see what you'll do. They're already operating. The constants of nature, things like the speed of light, the strength of gravity, the behavior of electrons, aren't negotiable. They don't vary based on opinion or intent. They're just true. And because of that, certain things were always going to happen. Stars were always going to form, planets were always going to coalesce, light was always going to travel at its particular pace, entropy was always going to increase. The structure was already in motion before you showed up, and once you did, you became part of it. Not outside of it, not above it, part of it. You're not watching the story, you're inside the story. That doesn't mean your life is scripted, it means the set has already been built. The laws are already in place, the variables are already in motion, and you've been dropped into that system, not to follow a fixed path, but to play your part inside a rule-based world. And the longer you live in that system, the more you see how deep the pre-written layers go. Every signal you receive, visual, auditory, tactile, has already begun its journey. The light has already left its source. The sound has already been made. The surface you're touching was shaped by forces far older than your lifetime, so when you react, you're reacting to something that already happened. Even your thoughts are structured by earlier inputs, memories, sensations, the content you've absorbed. Your brain is responding to stimuli that entered it milliseconds ago, seconds ago, decades ago. You feel spontaneous, but you're built from echoes, and that's not a limitation, it's just context. You exist as a boundary between what was and what could be. You don't control the story that led to your moment, but you do get to respond to it, and in your response, you write new details into the next moment. Your reaction becomes the new cause, the new input, the new variable. That's the paradox. You're both living in a story already told, and helping tell the part that hasn't happened yet. You're not the author, but you're not a reader either. You're something in between. A co-writer who doesn't know what's on the next page until you write the next word. But even that word, your choice, your movement, your change, is shaped by everything that came before it. Your voice exists because air pressure behaves a certain way. Your thoughts exist because neurons fire in patterns shaped by evolution. Your body moves because muscles respond to signals encoded in a structure defined by DNA, which was shaped by choices made by ancestors you never met. None of that was up to you, but you still get to be here, you still get to participate, and every time you do, you send out a signal, a word, a sound, a movement, a decision, a piece of yourself that gets folded back into the system, and someone else, somewhere else, will receive it. They'll read it as part of their story, and they'll respond. So the story is never entirely yours, but it's also never entirely not yours. It's being told constantly, by physics, by light, by chance, by pattern, by choice. And in every moment you add a sentence, even if you don't know where it fits. When you think about time, you probably picture a line. That's how it's usually drawn, a straight path from past to future, with the present sliding along it like a bead on a string. Left is behind you, right is ahead, a single axis, neat and tidy, one direction, one dimension. That image is easy to work with. It fits how we talk about time. It fits clocks and calendars. You're born, you age, you die. You remember yesterday, you imagine tomorrow. The present is the thin part, the only part you can touch. Everything else is either over or still waiting. But time doesn't really work like that. It doesn't behave like a line. That idea, time as a single thread through which you move, is a simplification, a tool, a map that's useful for daily life but loses accuracy at larger scales. Because when you zoom out, when you include the rest of the universe, you find that time isn't separate from space. It doesn't run independently. It's woven into the structure of the universe itself. In Einstein's theory of relativity, time is part of a four-dimensional system called spacetime. That's not a metaphor, it's the actual shape of reality. Space and time are coordinates on the same grid. One doesn't exist without the other, and in that system there's no universal now, no single moment that applies everywhere. Your present isn't the same as someone else's present, depending on how fast they're moving or how close they are to a strong gravitational field. That might sound theoretical, but it's measurable. Astronauts who spend time on the International Space Station come back to Earth having aged slightly less than people who stayed here. Not a lot, just milliseconds, but real, confirmed. Their clock moved differently, their thread stretched in a different way. This isn't science fiction, it's physics. The faster you go, the slower your time runs, compared to people who aren't moving with you. The stronger the gravity you're near, the more it pulls on your clock, the more it bends your timeline, and that means the idea of a single straight line doesn't hold up. Time can stretch, it can compress, it can diverge. Two people starting from the same moment can end up at slightly different points on the clock, not because something broke, but because their path through space-time followed different curves. If you could see time from outside, if you could step away from the flow and look at it all at once, you wouldn't see a line, you'd see a thread, twisted, tensioned, intertwined with all the others. Every point in space-time is connected to every other by light, by gravity, by motion. There is no isolated moment. Everything is part of the weave. You are part of it too. The thread that is you, your life, your history, your experience, isn't a straight passage from beginning to end. It's a curve through a larger structure. It intersects with other threads. It bends with gravity. It stretches under motion. It wraps around events. It responds to forces you can't feel. And even though you experience it in sequence, 1 second after another, that sequence is personal, subjective, unique to your path. There are versions of you, moving slightly faster or slower in timelines that technically exist but are inaccessible. Not alternate realities, just different experiences of the same one. And that's what makes the thread idea more accurate. It allows for shape. A thread has tension, texture. You can loop it, knot it, tangle it with others. It has dimension. It occupies space. And like time, it responds to what's around it. If time were just a line, there'd be no difference between living at the bottom of the ocean and living on a mountaintop. But there is. Time moves more slowly where gravity is stronger. That's not a thought experiment. That's measurable. You and someone standing 1,000 feet above you are experiencing slightly different durations. The longer you live, the more those differences add up. Your body doesn't notice. Your brain can't tell. But your clock can. And if you go farther, into orbit, or past a black hole, those effects become extreme. The shape of your time gets pulled. Not metaphorically, mathematically. You move forward, but not uniformly, not in lockstep with the rest of the universe. So while it feels like we're all marching together through time, we aren't. We're each following our own thread. And because those threads exist in space-time, not just in time, they're all part of a shared structure, a fabric, not a road. That structure includes the past, not as a memory, but as a place. A region of space-time that still exists, still obeys the laws of physics, still has coordinates. You can't get there. Not with our current understanding, but it's there, and so is the future. Not as a prediction, as a location, a part of the structure that hasn't reached your experience yet but already has properties. This view is called the block universe. It's a model where all of time, past, present and future, exists simultaneously as part of a 4-dimensional shape. Your consciousness moves through it, frame by frame, like a needle running through cloth. But the cloth was always there. Your thread is tracing a path. It's not making the fabric. It's exploring it. And depending on how you move, your path bends. Depending on where you are, your rate of movement through time changes. Depending on who you're with, your threads may align for a while, or pull apart or loop around each other without knowing. You feel continuous, but you're stitched into a larger pattern, and once you accept that, the question shifts. You stop asking where time goes, you start asking where it already is. Because the light you see, the gravity you feel, the clock you check, they're not passive markers. They're part of the geometry. They don't just measure time, they define it. If a massive object moves through space-time, it curves it. It reshapes the threads around it. That's what gravity is. Not a force, but a bending of the grid. You're sitting in that curvature now. Your thread bends with the Earth's mass. You're not falling. You're following the slope. And so is your time. It doesn't move at the same speed as it would in empty space. It doesn't behave the same way it would on another planet or in another galaxy or near a neutron star. And yet, you feel normal. Because everything you know is moving with you. Your body, your mind, your perception. So the shape of your thread feels like a straight line. But it isn't. It's curved by your environment, woven by your history, twisted by motion, and stretched across the fabric of the universe. You're not on a train riding through time. You are the train, and the tracks, and the passenger. You're not moving through a timeline. You're living on a thread. Light doesn't stick around. It moves. That's what it does. It begins at a source, picks up information about what it reflects or passes through, and then it keeps going. No matter what it hits, no matter what it shows, it doesn't wait. It travels, and once it leaves, it doesn't come back. Your life is full of light. It fills every room you stand in, reflects off every surface you touch, bounces off your skin, catches in your eyes. You don't feel it leave. You don't notice when it escapes. But it does. Constantly. Moment by moment, light is leaving you. It's carrying your shape, your motion, your temperature, your presence. Even the faintest bit of reflected light contains some part of your reality. The way your hand moved, the exact angle of your head, the texture of what you wore. Not symbolic traces, physical ones. The actual photons are encoded with that information. They scatter, they spread, they travel. Most of that light never makes it far. It hits a wall, a ceiling, a tree. It gets absorbed, lost to heat. It doesn't leave a trail you can follow. But some of it, especially what escapes upward into open space, keeps going. And once it's gone, it's still real. It's not a metaphor when scientists say we're shining outward into the universe. It's not poetry when they describe Earth as glowing. It's literal. Every second, the planet radiates light in all directions, visible, infrared, radio, and every second that light expands. If you were somewhere far away with the right instruments and you pointed them at Earth, you could detect us. Not just the planet, but the details. Its colour, its temperature, its atmosphere. And with enough data, you could start to separate the components. Clouds, oceans, vegetation, cities, human activity. And in that blur of signals, your contribution is there. It's microscopic, yes, just one person, but not nothing. You reflect, you emit, you alter your surroundings, you make changes that light records whether you ask it to or not. You don't leave light behind on purpose, but you still do. And once it leaves you, it becomes part of a record you'll never see. The universe doesn't save it in a folder, it doesn't organize or archive, but it doesn't destroy it either. Light keeps going until it's blocked, or absorbed, or stretched so far by expansion that it becomes part of the background. Until that happens, it still exists. There are moments from your life right now that are already 1,000 kilometers away, in the form of light. There are photons that reflected off your face seconds ago, that are now out of range, never coming back. They'll never be seen again unless something catches them, but that doesn't mean they're gone. They've just moved on. The farther out they go, the harder they are to detect, but they're still part of the expanding shell of information leaving the planet, a growing sphere of light moving at 299,492 kilometers per second, containing a flickering imprint of what's happening here. You've added to that sphere since the moment you were born. Every time you stepped into the sun, every time you turned on a light, every time you moved through an open space or stood by a window or lit a screen, you didn't just see light, you gave it back. You scattered it, redirected it, changed its path. You might not feel like you're doing anything important when you walk across a room, but the light that hits you sees it, records it, leaves with it. The universe notices everything in that sense, not in judgment, not in memory, but in motion. There are no quiet moments in physics, no real stillness. Even when you're not doing anything, energy is shifting, radiation is moving, particles are in flux, and every one of those shifts creates light. Sometimes you're the source, sometimes you're the surface, sometimes you're the thing that reflects, but always something is leaving you. And that creates a strange kind of presence, one that continues long after you've moved on. You don't stay in a room after you leave, but some of the light that touched you might. You don't stay in a moment once it's passed, but the light from it keeps travelling, and that includes every moment of your life. Every single one of them has already started radiating outward. You can't follow it, you can't retrieve it, you can't edit it, but it's out there. And in that way you continue existing, not as memory, but as signal. We don't think of ourselves as senders, we think of ourselves as receivers. We hear, we see, we process what's around us, but we don't feel the act of transmission. We don't feel the light that's leaving us, we don't know what we're sending, and yet we send it. If someone were out there, somewhere in deep space, with an impossibly powerful telescope, tuned to just the right frequency, they could, in theory, reconstruct something. Maybe not a full image, maybe not your face, but a pattern, a motion, a statistical shape, something that shows you were there, not just a person, a specific one, at a specific moment. The odds are low, no one's likely watching. The distances are too vast, the light too faint, but it doesn't matter. The light still leaves, the possibility still exists. So your existence isn't limited to what you remember, or what others remember, or what you wrote down or recorded. Your existence has already been broadcast. Every version of you that ever moved through the world under light is already gone, not lost, just elsewhere. The light you leave behind isn't symbolic, it's measurable, traceable, transformable. It's just not recoverable from your point of view, but it's still real. And that makes your presence permanent in a way that memory can't match. You don't depend on being remembered. You don't need someone to speak your name or hold your image in their mind. You've already interacted with the physical world in ways that can't be reversed. Your gravity pulled, your heat radiated, your shape reflected, your light escaped, and all of it is already on its way out, part of the expanding edge of Earth's visibility. Your influence isn't poetic, it's physical, even if no one ever sees it, even if it never matters to anyone else. It's already happening. You don't have to chase meaning in the light you leave. You don't need it to say something. You don't need it to prove something. Its value isn't in the message. It's in the fact that the message exists at all. You lived in a way that caused the universe to adjust, even slightly, even momentarily. That adjustment, the shape of your motion, the energy of your presence, the reflection of your surface, became part of what the universe emitted. Not for you, not for anyone else, just as part of the system. And that system never forgets in the way people do. It doesn't remember names, but it doesn't misplace information either, so you've already left a version of yourself behind. Not in the past, but in the light. It doesn't always feel like what you're doing matters. Most of the time, things are quiet. You're making coffee, checking your phone, walking to the next place. No one's recording it. You're not making history, but something's always happening. Something's always being sent. Because every moment, whether you notice it or not, is broadcasting. You move and light responds. You speak and waves ripple. You exist, and that existence disturbs the world around you in ways that can't be undone. Your body generates heat. Your steps create pressure. Your voice stirs air. You don't need to try. You don't need to intend anything. It just happens. Even if you lie still in the dark, signals still leave you. Infrared radiation from your skin, static electricity from your clothes, micro movements of air from your breath. Information is always escaping. That's what it means to be part of a system like this one. We usually think of messages as things we choose to send, words, images, signals with a purpose. But in physical terms, a message is any transfer of information, anything that travels from one place to another and changes what's possible on the other side. By that definition, every moment you live sends something. Maybe no one's listening, maybe it's never received, but it's sent. That's not philosophy, it's physics. The configuration of atoms in the room changes slightly when you enter. Not permanently, not dramatically, but measurably. Your presence causes molecules to shift, reflects light differently, bends sound in new ways, and every one of those shifts carries data. Not encoded deliberately, but embedded in the outcome. And once those changes occur, they start to spread. Light reflects off you and moves outward. Sound pushes into walls. Surfaces warm up slightly under your contact. Every part of the environment adjusts to your existence, and that adjustment becomes the new condition, the new starting point for what happens next. So what's happening now, whatever it is already leaving a trace, a message from this specific version of the world with you in it. Even if that message is faint, even if it disappears quickly, it's still part of the story. And that story doesn't need to be big, because small messages matter too. A single photon of light carries information. A single vibration can shift the state of a system. A whisper of warmth can affect the behavior of the molecules around it. We live inside a network of continuous exchange. Everything is connected by cause and effect, by pressure and motion, by energy and direction. And every action, every presence, even every inaction, fits into that exchange. So every moment is doing more than just passing by. It's adding something. And that includes moments you've forgotten, the ones that seem too ordinary to remember. They still created motion, still pushed energy outward, still sent messages into the system. They're not stored in your memory, but they're stored in the history of the world itself. They happened. They were registered by the laws of physics. They were processed by atoms, recorded in the paths of light, translated into changes in temperature and momentum and balance. They became the conditions for the next moment, and so on. That's why every second you're alive is more than just a waiting period between events. It's an event. It's an emission. Something is leaving you. Something is being broadcast. And that broadcast keeps travelling. Not in a straight line, but through layers. It reflects. It refracts. It dissipates. Some parts fade quickly. Others last longer. A few, especially light that escapes the atmosphere, might travel for years without interruption. You won't know what messages survive. You won't know what reaches someone else or when. But the sending never stops. And that sending doesn't just come from light or heat. It comes from interaction. Your behavior affects other people, sometimes obviously, sometimes invisibly. A word changes someone's thoughts. A look changes someone's mood. A decision you don't think twice about alters the course of something you'll never see. We don't track most of this, we can't. There are too many variables, too many unknowns. But the complexity doesn't make the message less real. In fact, it makes it more important. Because even the smallest contribution matters in a system this interconnected. You might never know what your presence did to a space, but the space knew, the particles knew, the light knew. And that was enough to make it different from what it was before. That difference is the message. It's not always clear what's being communicated, but that's not necessary. You don't need to write a sentence to send a message. You just need to act or exist. And once you do, the universe incorporates it. That's what it does. It doesn't pick favorites. It doesn't prioritize. It doesn't judge the quality or the meaning. It just lets every input modify the system. That's how physical laws work. They don't wait to decide whether your moment matters. They respond. That's what gives your life shape. Not just memory, not just identity, but transmission. The fact that you can't exist quietly. That even your silence contains movement. that even your stillness changes the conditions. You don't choose what kind of message you send, not all the time, but you do send one, and because the universe doesn't delete, that message continues. It becomes background, becomes noise, becomes structure, but it doesn't vanish. You may never know what the moment you're living now will become later. It might be forgotten in your mind, it might be invisible in the memories of others, but it might be the reason something small happens that otherwise wouldn't have. Maybe a piece of light from your window reflects just right and helps a plant bend a certain way. Maybe a sentence you mutter to yourself influences a decision that affects someone next to you. Maybe a quiet action becomes someone's reference point in a moment of uncertainty. It's not about the scale, it's about the fact that something moved. And because that movement was specific to you, it means you sent it. Even if no one ever finds it, even if no one ever knows it came from you, even if you never think of it again, it already left. Every moment is like that, even this one. You fall asleep in one moment and wake up in another. No conscious crossing, no awareness of the transition, just absence, then return. And yet, everything continues while you're gone. Light still travels, the planet still turns, the story doesn't stop. Sleep feels like pause, but it's not. Your body keeps working, your mind keeps sorting. Somewhere beneath the surface, memory is being restructured, threads reconnected, ideas reprocessed. You're not inactive, you're just somewhere else for a while, and the world moves on without you, quietly, reliably. The clock keeps counting, the stars keep sending, signals keep arriving, information keeps flowing. When you sleep, you're most present to yourself. You're sealed off, disconnected from conversation, from reaction, from the immediate signals of the world. And at the same time, you're never more open to what's already happened. Dreams don't use live data. They build from what you've already stored, from sound and memory and images and patterns, from things you've seen but didn't fully process, from moments you forgot you noticed. In that way, dreaming is a conversation with the past, not just your past, the world's past filtered through you, the shape of a building you walked by once, the voice of someone you used to know, a flash of something you didn't think you remembered. All of it arrives again, rearranged, reassembled, without context or sequence. Your brain isn't trying to tell a coherent story. It's trying to find one. So it pulls from the archive, and the archive is full of past light. Every image in your mind, real or imagined, was built from light that reached you earlier. Not abstract light, specific photons, ones that reflected off surfaces, entered your eyes, triggered electrical activity, left a trace. Those traces don't vanish. They fade, get refiled, reshaped, but they remain somewhere, encoded in the pathways you carry. And when your waking filters shut down, your brain starts sampling that data in a different way. That's dreaming. Not travel, not vision, not prediction, just pattern recognition with the input reversed. You're not responding to what's around you. You're running simulations based on what's already passed through you. So your dreams aren't from nowhere. They're echoes, reconstructions, partial reflections of signals that once reached you, stitched together by a mind that's trying to restore balance. And that's why some dreams feel timeless. They're built from pieces that don't belong to any single moment. The shape of a road from one year, the sky from another, a voice from somewhere in between. You're not dreaming the present. You're building from light that already left. And even when the images are new, impossible, surreal, fictional, they're still composed from prior input. There's no other material. The mind can only build with what it's received. So when you close your eyes, you become a projector of past light. Not consciously, not deliberately, but structurally. You sleep in the present, but you dream in the past. And while that sounds poetic, it's just physics and memory combined. Because nothing in your mind came from nothing. Everything that lives there started as data. and that data had a source, a surface, a signal, a direction. Some of it came from the stars, some from other people, some from your own actions reflected back to you. But all of it arrived before you used it. And while you sleep, the barriers between inputs soften. Your system isn't waiting for new light. It's reinterpreting the old. That's why dreams can feel familiar and strange at the same time. You know the pieces, but not like that. Not in that order, not with those meanings. It's the past, unthreaded, spliced, loosened from cause and effect. You've spent your whole life being shaped by the light you've received. Even now, that light is still moving. Some of it is stored as memory, some of it as knowledge, some as feeling. But every piece of it shaped the way your thread curves through the world. You don't carry it like baggage. You carry it like infrastructure. And when the noise of the present quiets, when the inputs slow, your mind loops back to that foundation. It plays back impressions, guesses, hopes and fears, not to confuse you, but to keep the system running. Sleep isn't an escape from time. It's part of it. It lets the machinery reset, lets the noise settle, lets the signals recombine in ways they can't during waking. And even though time doesn't stop while you rest, your awareness of it loosens, the sequencing fades, the timeline softens, and for a few hours you live without direction. There's value in that, because when you return you do so freshly reattached. Your mind recenters, your perception updates, you become ready to receive new light, not better light, just newer. And as that new light arrives, it joins the same system as the rest. It reflects, it informs, it leaves, and someday, maybe much later, pieces of that light will make their way back. Not as themselves, not as recognizable signals, but as fragments in a dream, a memory recolored, a voice retuned, a location remembered only by the way it felt. You won't trace them to their source. You won't say, this came from that moment. But that won't make them less real. That's how the system works. Input becomes output. Output becomes condition. Condition becomes memory. Memory becomes experience. Even in sleep, you're part of the pattern. Even in dreams, you're reading old messages from light that's already moved on. So when you rest, when the room quiets and the world fades, you're not stepping out of time. You're changing how you experience it. You're still here, still sending heat, still processing signals, still giving off the quiet radiation that tells the universe where you are. But for a while your focus changes, and you let the past run loops around the present. The message doesn't stop, it just changes form. Thanks for spending this time with me. If this made you feel calm, or curious, or just a little softer inside your own thoughts, you can always come back. There's more here. Or you can close your eyes now and let the rest of the universe continue without needing you to catch up. Sleep well. You've already sent enough light for one night. Good night from Science for Sleep.